Okay, good. Okay, Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon to everyone. This is our third class for DCE 6953, Multivariate Statistics for Social Science. We have already completed our discussion last week where we discussed on the data screening. That will be a crucial part in the data preparation when you start to work on your data analysis. So before we do anything, so we go through the procedure on data screening, in addition to what we have already discussed for ERS 5950, where we did the 7-step in data preparation. But in that 7-step in data preparation, when we did our run frequency in step number 3, and then step number 4, we do the data editing for those data that are not been correctly entered. But in this case, we go beyond that. I mean, when we go for, we check on the, of course, the data entry. In addition to that, we go for data screening, as well as we go for the case screening, as well as the what the other one. So that means we have basically
variable screening.
Variable screening, case screening, and variable screening. So that means we go beyond the what we have discussed in 5950. So that means since we have already gone through this procedure, so my suggestion will be when you want to work on your data analysis, so we expand the step 3 and 4 to include the data screening, which include case screening as well as variable screening. Okay, so we hope that everyone have a better picture of what to expect, what need to be done when we go for data screening. So we just follow the procedure as described in our class discussion, as well as when you did your assignment, when you did your assignment 1, then we hope that that will give you a better perspective on what need to be done when you go for data screening. Okay. What we are going to discuss today will be another topic which will be also done at the early part of your research, the early part of your data analysis. I mean, after you have gone through the data preparation, then would be a good idea for you to proceed to the topic that we're going to discuss today, which is on EFA, where EFA stands for Exploratory Factor Analysis. So basically, we have 2 different types of factor analysis. We have EFA, which will be conducted in Spss, and we have another factor analysis, but that will be confirmatory factor analysis, which is CFA. What we are going to discuss is EFA, but there is another one called CFA, confirmatory factor analysis. But this confirmatory factor analysis need to be done in SAM apps. I mean, you need to use, among others, you can use your MOS to work on the CFA, which is confirmatory factor analysis. And I will share afterward in the early part of our discussion for this topic, the difference between EFA and CFA. Of course, we know by now, EFA is done in Spss, but the other one, which is CFA, need to be done in SAM application. So the one that we normally apply will be, we are using MOS for that purpose. Okay. This EFA, we have different school of thought for different individuals. Some people have the school of thought in the sense that it is compulsory. I mean, before you can proceed with your data analysis, after you have done your data preparation, you need to run through the EFA. And then to them, it is considered to be compulsory. I mean, there is no option. You have to go through EFA before you go through before you proceed on the actual analysis for your data. But that is one school of thought. Another school of thought is EFA is considered as something that is optional. I mean, something that is highly recommended, but not to reach the stage of compulsory. So that means we have 2 schools of thought. So similarly, your supervisor may be in the first school of thought, or maybe your supervisor will be in the second school of thought. If it is in the first school of thought, then you may have some problem especially when you run for your EFA, your EFA doesn't match with what you plan for. I mean, let's say in your study, you plan for 5 independent variable and you plan for 1 dependent variable. But when you run for your EFA, maybe it doesn't jive with what you propose in your research framework. Maybe some of the item that you plan or that you have developed for, let's say, IV1, go to maybe IV5. Some of the item in IB2 may go to your DV. So that means if that happens, then and your supervisor is in this first school of thought where it is considered to be compulsory, that means you have hard time to convince your supervisor saying that yes, it is good to have to run for this EFA, but it is not to the stage whereby it is compulsory. I mean, it is highly recommended to be applied or to be run, but not compulsory. So my school of thought is I go for the second one. I mean, I consider EFA to be highly recommended, but it is not considered to be compulsory. If you get, especially if you get your result of your EFA that jive with what you propose in your research framework, with what you propose in your instrument, then well and good. Of course, it will be better for you to present the result for EFA, and that will also give credibility to your instrument as well as your data. But maybe sometimes if you're not that lucky, when you run for your EFA, it might not jive. If that's the case, then we may want to keep aside, and then we just proceed on for CFA when we go for set a structural equation modeling. So that means we have 2 schools of thought in relation to EFA. The first school of thought is compulsory. The second school of thought is highly recommended. And that means it's optional. But even though it's optional, but it is highly recommended for you to run for this EFA, right? Okay. So how many of you have already run EFA before? Anybody here? Based on your own experience, how many of you have applied EFA before in SPSS? Hasilinda macam nak responnya. Okay, Hasilinda, have you ever used EFA before, factor analysis in SPSS?
No.
No. Okay, what about Dora? Okay, Dora, have you run EFA before?
Yes, Prof. I have run the EFA for the manuscript for publication.
Okay, all right, yeah, of course, especially when you want to publish your paper, some reviewer insists that they need to see the result of your EFA. What about Rizwan? Rizwan, have you run EFA before?
Not yet.
Oh, belum lagi. Okay, not yet. I mean, positive thinking, not to say that I'm not going to apply EFA, but maybe for the moment there is no opinion need, but maybe later, especially for PhD studies, we may want to run for this EFA. Yogasri, have you run your EFA before in SPSS? We have 2 of our members up in here where they sit on the beach for the class. Not yet. Okay. All right. Okay. So what we are going to discuss today will be, we want to expose for those who don't have any exposure yet on EFA. So we want to make sure that everyone will be exposed to what do you mean by EFA, what is it for, and how to proceed to run for EFA in SPSS. So for that purpose, let's go for our notes. Okay. Notes. Okay, factor analysis. When we say factor analysis, we are referring to EFA, that means exploratory factor analysis. But if you go for SAM, structural equation modeling, we don't say factor analysis, but we always say full confirmatory factor analysis. But sometimes when we go for, when we run for SPSS, for EFA, sometimes we just use the term factor analysis, but this is understood, we are referring to EFA, exploratory factor analysis. a process of dimension reduction. It's a process of dimension reduction, and that is what is used in Spss. If you were to choose for Efa, it indicates there for dimension reduction. Okay, let's overview the research process. I mean, if you were to embark on a research project, especially if you are doing your PhD, of course, if a registered student will be PhDs. For masters, maybe you are just sit in because it is not that mean you are not supposed to register because it's 6,000 CC only for PhD student. Okay, let's go through the process of research procedure. Okay, a good research will always start with a strong theoretical foundation. I mean, we start with theory. This is the first step. I mean, once you have identified what is it that you want to study, I mean, what should be your dependent variable that you want to work on for your study. And that normally when we want to identify research project, we always identify what is the dependent variable that I want to study. So once I have identified the dependent variable, then I will try to look through the literature related theories that can be used to establish your research framework. Right? We need to look for theories, and the theory is related to your dependent variable. The theory that relate to your dependent variable. And then once you have identified theory, maybe one main theory and maybe other supporting theory, then from that theory, it will list down, it will display what are the constructs involved in that theory. I mean, the construct will be, the DV will be your opinion, the variable that you want to study. And then you have series of maybe your independent variable on the left. And maybe also at times we have mediating variable as well as moderating variable. I mean, when you identify the theory, then we should be able to pinpoint what are the constructs involved in that theory, right? I mean, we have individual construct to be measured and to be studied. Okay, next step will be, we look for instrument that can be used to measure each of the construct, each of the independent variable, and also your dependent variable, because in most cases, we have one dependent variable in one study. So that's why I say for each of the independent variable and as well as the dependent variable, we need to look for specific instrument that we can use to measure our variable or our construct. So in most cases, if your study is not to develop instrument, then we don't have to develop instrument on our own. Right? We don't have to. But what is a good strategy will be look through the literature, especially established instrument that has been used to measure that set of construct in your research framework. Right? I mean, we just maybe we just go for some adaptation to the existing instrument. I mean, we have identified what are the construct, and we also identified which instrument that we can use in order to work on our to measure that individual construct. And why I said we need to choose, because especially if you are using structural equation modeling for your data analysis. So as much as possible, we don't want an instrument for a construct that consists too many items or too many indicators, because when we talk about structural equation modeling, I mean, we want to draw the individual item in your path diagram, right? So if you have too many items to represent one construct, then your path diagram will become very crowded, and a lot of time when you have too many items to represent construct, then you might not be able to get model fit. That is what we want. When we go for SEM, we want to make sure that we get the model fit. So that means when you go for structural equation modeling, especially when you are using the covariant-based structural equation modeling, example MOS, then you must make sure that each instrument that you use in your study must meet the model fit. That means when we go for structural equation modeling, we have three phases or three stages in the SAM analysis. We start with CFA, which is confirmatory factor analysis. We follow by measurement model, the second stage, and finally the structural model. For each of the stages in the SAM analysis, we want to make sure that it meets the model fit. So therefore, not necessarily when you have your data, you get your result to be that you can present. It's not as easy as that. Will be more challenging because unless and until you get you can show that it meet the model fit for all the three stages, then only you can present your result. So on the contrary, if you were to run your data analysis using Spss, if you have your data, right, and then just make sure that the instruments are all up in a reliable, and then you should be able to get your result, and you should be able to proceed to present your result, and you should be able to discuss your result in your thesis or in your report. That means there is no hassle for you to make sure that you have to get model fit for your instrument. So in this case, for SAM, you must make sure that it meet the model fit. So that's why when we have our construct, maybe we have 5 construct or 6 construct or whatever in your research framework. So as much as possible, if you have the choice to choose, then make sure, try to choose an instrument that has less item. But of course, we want to make sure that the instrument is established instrument, not just instrument developed by one bachelor student to measure that construct, developed by that bachelor student, but you are going to use that instrument for your PhD study. Maybe that is not that good, but you want to make sure that you have credible instrument to be used to measure your variable or construct. So here we have item that represent each construct, and then you proceed to do your data collection, depending on what is the nature of your data collection, maybe online, or maybe your data collection through a personal interview or whatever, right? So that means you proceed with the data collection, and then after that you have two choices. Either you straight away go to CFA. That means if you straight away go for CFA, that means this is the second school of thought, which we thought that it is an optional. That means it's not compulsory for you to go through EFA. But if we go through the first school of thought, that means instead of from the data that we have gathered, we can straight away go for CFA. We need to go through the data field. That means we go through the data screening, data preparation, data screening, everything. And then we proceed to EFA, where EFA is our topic for today, which is exploratory factor analysis. And then from there, we should be able to establish more credible instrument comprises of item that has high factor loading that correlate highly together. So that means we hope that when we go through EFA, the result that we get will mesh with the instrument that we use for that particular research. Okay, after EFA, then we go back and then we try to make sure that the item fall into the right instrument or the right construct. And then from there, we proceed to, after that, then only we go for CFA. After going through EFA, now we go for CFA. And then after we have conducted EFA, which is confirmatory factor analysis, maybe we need to do some modification to the item. Maybe some item need to be dropped, or maybe some item need to be correlated, right? And then after we have it meet the model fit, everything for the CFA, and then we check for in CFA we also check for convergent validity, and we make sure that it meet the convergent validity as well as construct reliability. And that will be the 3 tasks that we need to perform in CFA. So for those who have attended or have read through or have gone through structural equation modeling, you should know by now in your CFA, there are 3 tasks that we need to perform. The first task will be check for model fit. The second task will be for every instrument that we have in our framework, we must make sure that it meets the convergent validity, right? First will be model fit, second convergent validity, and finally, we want to make sure that each instrument meet the construct reliability. And this construct reliability, when we run in Amos, it is comparable to our Cronbach alpha that we do in SPSS. That means if you have checked your construct reliability in Amos, you don't have to run your Cronbach alpha in SPSS because these two are comparable. The value will be comparable. So we are testing for the reliability for the instrument. Okay. Okay. Next.
Prof,
Yeah.
Prof, I have a question.
Yeah.
Is convergent validity is the same with predictive validity and criterion validity?
Okay. There are two different type of actually there are different type of validity. We have phase validity, content validity, right? But here we are talking about construct validity. I mean, statistically, we want to test whether it meets construct validity. I mean, when we talk about construct validity, it comprises two types of construct validity. One is convergent validity. The other one is discriminant validity. Convergent and discriminant. So the first test for validity we conduct in CFA, where for every instrument that we run for SAM in stage 1, then we will check for convergent validity. What do you mean by convergent validity? Okay, earlier we have already identified instrument to measure, let's say, our dependent variable, which comprises 7 items. And then when we run for EFA, all the 7 items mesh, I mean, it come together as one factor. I mean, it is nice. I mean, everything fall into the basket. I mean, all the items converge together. I mean, to measure that construct, and then to make sure that it meet the convergent validity. When we run for CFA in Amos, then we test for convergent validity. What do you mean by convergent validity? This set of items that we develop to measure that construct together, they really commonly they measure that construct. I mean, together they measure that construct. That is what we call by convergent validity. So in order to test for convergent validity, that means there will be certain statistics that we are going to use, and there will be also decision criteria that we need to refer to in order to test whether it meet or it doesn't meet the convergent validity. So we want, as much as possible, we want to make sure that our instrument meet the convergent validity so that all these items together, they converge toward one common construct. Okay, that is the first construct validity. Okay, the next step in step 2 in measurement model, in your structural equation modeling, in measurement model, we combine all these construct together, all your IV and your DV together in one model, and that model is called measurement model. So when we go for measurement model, we conduct another construct validity, and that will be discriminant validity. What do you mean by discriminant validity? If you were to take any two constructs, let's say one IV and the DV, two different constructs. So we want to make sure that these two variables, these two constructs, discriminate each other. I mean, they are. Pardon me? Somebody waiting?
Somebody
Hello,
waiting.
Proof.
Yeah.
Sorry to interrupt you. There are still students. They are waiting to come in.
Okay.
There are still several students. They are waiting to come in.
Yeah, because they are asking for trouble. They are asking for trouble.
Sorry.
I always have to remind our members, as much as possible, try to be on time. But I have already admitted 5 of them. Because just now I went to the mosque for Zuhur prayer. But after prayer, I immediately come back to home so that I will be on time to start our session. So as much as possible, another gentle reminder, try to be on time, because the tendency is once I start to talk, even though there are messages listed on the screen, but sometimes I overlook because of the excitement to share knowledge with our fellow members here. Okay, so just a gentle reminder, if possible, next time, come together. Okay, so in this case, if we were to look at them, actually, if you were to refer to our diagram here, there is one theory that I just put up in it forward as one example. If let's say in this case, theory of planned behavior, that means the behavior is your dependent variable that you want to study. I mean, this is quite a generic theory. I mean, any behavior can be used. We can use this theory. I mean, let's say whatever behavior that you want. Let's say you want to talk about participation, or you want to talk whatever. But I mean, this is quite a generic theory to be used. So, what are the variables? So, have attitude, subjective norm, and perceived behavior control as the independent variable, and we have intention as the mediating variable. So that means this will be, that means we want to make sure that when we run for CFA, we will run the CFA for the individual construct separately. That means we run for attitude, we run for subjective norm, we run for perceived behavior control, we run for intention, and finally we run for behavior independently. Right? I mean, it needs to be done separately, not to combine together. But after we have done for CFA, it meet the model fit, it meet the convergent validity, the individual construct meet the construct reliability. Then we proceed to the second stage, which is the measurement model, where we combine all these variables together, but we don't have to declare which of this will be the independent variable, which of this will be the dependent variable, and which of this is our mediating variable. We just lump them as one group of variable together in one structure, and that structure is called measurement model. Okay, in the measurement model, then we test for our discriminant validity. That means if we were to take any two construct, we want to make sure that these two constructs discriminate each other. That means it is a unique variable by itself. That means this set of items really measure the dependent variable. This set of items really measure your independent variable, one of the independent variable. I mean, there will be not so much of interrelationship between item for DV and the IV. So that will be the second stage, where we run for the discriminant validity. In addition to that, of course, we also test for model fit. We also test for assumption of normality. We also test for the presence of outlier in this particular case, right? Our second stage. And to me, when I share my knowledge on SAM, I would consider stage 1 and stage 2, which are CFA and measurement model, as just data preparation. Right? I don't consider that as the actual analysis to be done. So these two stages, CFA, measurement model, is just considered as data preparation for your structural equation modeling. And in most cases, I would suggest to my student, result for these two stages, CFA and measurement model, we just need to present in chapter 3. When you present your methodology, there is one subsection or some subtopic called data analysis. You can just present the result of these two stages, CFA, measurement model, in just chapter 3 under data analysis. So what is it to be presented in our chapter 4? Okay, the result for chapter 4, what is it to be presented in chapter 4 will be result for your stage 3, which is structural model. I mean, the structural model, result for structural model will be used to answer your objective as well as used to answer your hypothesis. That result will be presented in chapter 4. Okay, so that means these are the 3 stages: CFA, measurement model, and structural model. And in your structural model, we have all the construct together, but the difference between measurement model and structural model, in measurement model, we don't distinguish, we just combine all the set of variables together as one model. But when we prepare this structural model, then we need to declare which one will be the independent variable. If it is independent variable, we will place the construct on the left, just like what we have on the screen. If it is dependent variable or mediating variable, we place the variable on the right. That will be, that means we need to demarcate between independent and dependent variable. right? As well as if you have your mediating variable. In the term that we use in structural equation modeling, we have exogenous variable and we have also endogenous variable. Any idea about exogenous and endogenous variable? Yes, Gary. Or Nabila? Nabila want to respond? Any idea about? Yeah.
Exogenous is external, endogenous internal.
External and internal. What do you mean by external and internal? But another word is just exogenous is just your independent variable. I mean, another term that is coined in structural equation modeling to represent your. Sometimes they don't call by independent variable, but they call by a specific name, exogenous variable. That means the list of variable on the left. And then variable on the right, which include your dependent variable, as well as if you have your mediating variable, you call that as endogenous variable. So exogenous and endogenous variable, exogenous on the left, endogenous variable on the right. And the endogenous will, of course, include your dependent variable. If you have your mediating variable, will also be considered as endogenous variable and to be placed on the right of the path diagram. Okay, so that means you have your structure model. So that means in that structure model, then only we run the analysis to answer whatever objective that you have in your study. Unless, except for, if your study is to develop instrument, then these two stages here will be the gist of your data analysis. I mean, there is no need to proceed for structural model. We just stop at measurement model because we just want to develop instrument. Therefore, your CFA and your measurement model will be part of your chapter 4 because that will be your finding. It's not considered to be data preparation, but in most cases, in our study, we just need to have instrument to measure our construct, right? We are not going to develop our own. That means if your study is to develop instrument, then you just need to proceed on CFA, measurement model, full stop. And the result to be presented not in chapter 3, but in chapter 4, because that is your finding, right? So that means that is special case. So, and then in your structure model, then you test for the all the hypotheses that you have on relationship between variable, contribution of IV, DV, maybe you have testing for mediation effect, testing for moderation effect, and your result for your multiple linear regression will be able to be extracted from your structural model. I mean, the least that you can do for your structural model will be analysis related to your multiple linear regression, where we are testing on the overall model, we are testing on the contribution of individual IV on DV, and then we also want to describe about model summary, which include R squared. I mean, that will be what to expect when you go for your research, right? Your research. So, especially when you are doing your PhD, so make sure as much as possible incorporate the data screening, the data screening in your early part of your data analysis, as well as EFA, to make sure that we have a solid set of instrument as well as data to generate a result that can be used to answer your objective as well as your hypothesis. Okay, any question about this diagram, your overview of the research process? I hope everyone is clear, right? These are the steps that you need to go through until completion of your study, until your graduation, inshallah. Okay, let's proceed further. Okay, our topic is on EFA. Okay, that means if you can digest, that means by the end of this session, if you can get all this that I display on this slide, I mean, you have learned your EFA. I mean, I try to get everything in one slide. What is expected for you to learn and for you to understand and for you to be able to do when you work on your EFA. Okay, our topic is factor analysis. Of course, when we say factor analysis, I mean, we are referring to exploratory factor analysis. Okay, first of all, we want to discuss type of factor analysis. different type of factor analysis. So we have the when we run for the factor analysis afterward, it comprises two types. One will be to explain patterns within your data, patterns of your variable within your data. Second will be data reduction. I mean, you can use your EFA for these two purposes, either to look for patterns within your data for the variable or for the construct. Second will be to reduce the number of items, where we consider that as data reduction. Okay, that will be the two types. Second, we want to share step in FA, step in factor analysis. Okay, we have three stages. That's 3 steps. Step 1, this is we want to check whether is it appropriate for you to run EFA for your data set. So luckily in your Spss, we have 2 statistics given by Spss in order to test for whether your data is appropriate to be run for EFA. And the 2 statistics are Kaiser-Meyer-Olkin. The first one is Kaiser-Meyer-Olkin, KMO, where we are testing on adequacy for sample size, whether you have adequate sample size for EFA. The second statistic is Bartlett test of Sphericity. Bartlett test of Sphericity. We want to make sure that we have enough or adequate correlation among item, which will be appropriate for you to proceed for EFA. We don't want to have identity matrix in your data set. If you have identity matrix in your data set, I mean your data set is not valid to run for, or it's not good for you to run for EFA, because you will not get as what result that you are supposed to get. So we don't expect to have an identity matrix. What is identity matrix? We will discuss that one afterward. So, but that is what we want to avoid. Right? So that means this Bartlett test of Sphericity, we want to prove that our data is not an identity matrix. I mean, if it is not an identity matrix, I mean, it is appropriate for you to run for EFA. I mean, that will be, we want to test for appropriateness of your data for factor analysis. Okay, that will be stage 1. Stage 2, we want to determine how many factors to be extracted. Okay, out of the list of items that we enter into factor analysis, okay, how many factors that you want to extract from the analysis? Okay, we have 3 procedures that we can follow. Okay, the first criteria, which is the default criteria in Spss. I mean, if you were to run Spss, by default, if you don't set anything, that will be the method to be used, and that method is called Kaiser criterion. Kaiser criterion. What is Kaiser criterion? Kaiser criterion is eigenvalue more than 1. That will be the criteria to be used in order to establish how many factors to be extracted. Is it 2? Is it 3? Is it 4? The Kaiser criterion will give you, will indicate how many factors that we can extract from the result. The second option will be, we can use script plot. Script plot is an option that is provided by Spss, but by default it is not ticked. But if you want to run also for this script plot, then you just need to tick that option for script plot. I mean, from the script plot also, we should be able to get the number of items to be extracted. And the third method, in order to determine how many factors, we can use the Monte Carlo parallel analysis. Monte Carlo parallel analysis. This is, but the third method, Monte Carlo parallel analysis, it is not embedded in your Spss. I mean, if you want to use this third method, then we need to go to the internet, go to the specific website, and then we need to copy certain command from that website, and then we paste into our syntax editor, and we need to do some editing, and then we can run. And then when we run from that analysis, from the result, we should be able to get how many factors to be extracted. I mean, you can have these 3 methods in order to determine how many factors to be extracted. In addition to that, Spss also provide you as the researcher, you can inform or you can specify when you run for EFA, how many factors that you want. That means that will be considered as the fourth method. I mean, as a researcher, they say, based on your research framework, based on your instrument, they say your research framework, you have 3 IVs, you have 1 DV. I mean, you have basically 4 factors, 3 IV, 1 DV. So you want to force EFA to come up with 4 factors. That means that is another option in Spss that you can set in order to determine how many factors to be extracted. But if you were to use the software, I mean, you have the Kaiser criterion by default. Second will be script plot option in Spss. Third will be Monte Carlo parallel analysis, but we need to just copy the command and then we run in Spss. And the fourth will be you as the researcher. If let's say what is proposed by the 3 methods doesn't match with what you want to get, and then you can force as EFA to come out with the number of factors to be extracted. That will be the fourth. Okay, that will be the second step in your FA. And finally, the last step will be factor rotation. Factor rotation. So in most cases, even though we can get the result without the factor rotation, but it is highly recommended that we go through factor rotation so that we can get a more meaningful and more easy to read result from your factor analysis when we go for the factor rotation. And we have 2 different types of that factor rotation that we can select or we can choose. One is called orthogonal and the other one is called oblique method. I mean, we have orthogonal, which is uncorrelated, and we have the other one, oblique, which is correlated method. And normally for the orthogonal, we use Varimax as the procedure, and then for the oblique, we use direct oblique mean. I mean, all this, you have the option in Spss. You can just click the option, and you should be able to proceed with the factor rotation, right? Factor rotation. So in most cases, according to books and literature, if you were to use these 2 methods, the result will be comparable. The result will be comparable. But personally, my bias is I prefer to use the orthogonal, the uncorrelated method, where I use Varimax as the procedure for factor rotation, right? Factor rotation. But according to authors, in most cases, these 2 procedure will yield you comparable result for your factor rotation. Okay, that will be the step. Okay, next, we want to look at the statistics that are derived or that are generated from your factor analysis. The first statistic that we need to be familiar with will be communalities. Communalities, where from this communality, that means you should be able later on to determine what is the percentage of variance. I mean, from the communalities that you should be able to get the total percentage, because in order to get the total percentage, the formula is total communalities divide by number of items multiplied by 100. That will be the formula to be applied if you want to do manual calculation. But of course, the values are given from the output. All these values are given, but maybe for the sake of so that we can get the mechanic, we know the detail about the calculation. We will also go through the manual calculation, how to calculate the total communalities. And then from there, how can we calculate the total variance? And then we should be able also to calculate for eigenvalue. And then once we get the eigenvalue, then for each of the factor, we should be able to calculate the percentage variance based on the eigenvalue that we calculate based on the formula. Eigenvalue equal total factor loading squared. I mean, if we were to square each factor loading for each of the column, then we should be able to get the eigenvalue. And then based on the eigenvalue, we should be able to calculate percentage of variance explained for each of the factor. And finally, what next? After we have done the factor analysis, what next? So the first thing that we need to do will be, if let's say now this series of items that you generate, that you propose and that you run in factor analysis, you don't have any idea what factors or what variable will be derived from the result of your factor analysis, then the first thing that you need to do will be you need to look at each of the factor. And then what are the common themes? What are the common themes? And then based on the common theme, then you should be able to assign label to each of the factor. And this label will be the dimension or the variable for each of the factors that are being derived. But if let's say now you have your set of instrument, you have already have the name of your variable 1, 2, 3, 4, and so on and so forth. So you just proceed. Okay, these are the set item for variable 1. This is the set of item for the second variable, and so on and so forth. I mean, if you have already the variable name, so it's just matter for you to just identify. Okay, these are the item. After you have gone through, these are the item that will be used in order to measure construct number 1. These are the items that will be used to measure construct number 2, and so on and so forth. And then for each of the variable or dimension that you have, then we should proceed with the test of reliability. I mean, we go for reliability test. We are testing for the internal consistency for the instrument. And finally, we should be able to proceed to calculate the factor score. I mean, you have two choices. Either you can choose the option given in factor analysis, where you can save the for each of the factor score, or you can use your the normal way of calculating using compute. You can compute using your formula, and then you can use that formula that you have to compute for the factor score. That will be what to expect when you go for factor analysis. So we have two different types. And then in addition to that, I will also share you the difference between the Efa and Cfa. And then we share the two different types of factor analysis, and then the step in factor analysis, the 3 steps. And then also we share how the result for our statistic that we get from the output will be calculated or derived. Then we will show the manual calculation, how to get all the statistics. And finally, what next? Okay, just to share you one personal experience. There was one PhD candidate in the Viva where it happened that I was one of the examiner. Okay, and then it so happened that the candidate utilized factor analysis for the study, for that particular individual. And then when I look at the result, it doesn't mesh because we know that in order to get the percentage of variance for each of the factor, we know the formula, and when I try to use the formula, it doesn't jive with the result presented. So I asked the candidate, okay, I'm interested about your opinion result for your factor analysis, and by the way, how did you get all this percentage of variance for each of the construct? The candidate said, yes, I got from my Spss. And then I asked, if we were to look carefully, the value that you present doesn't jive with the actual value if we were to do the calculation. And then I asked the candidate, is it you who did the data analysis? Initially, the individual says, yes, he worked himself for the data analysis. But after several questions, and he admit, yes, somebody helped me to do the data analysis for the Efa. So if you were to present your result, don't mingle around with your with your result that you get, because sometimes maybe one of the examiners may be in a better position to screen through the result, and maybe the result that you present might not be right. So if the result is not right, for those who really have a little bit extra knowledge on the mechanics of how the results are being derived, then you will be questioned about the result. So I mean, if you start to expose that there is something not right with the data analysis, then people have big question mark on your data and the credibility of the result that you present in your thesis or in your dissertation. So never mingle around or that never doctored your data. So make sure, especially if you just change. There was also one case, and this is also another case, where student present result for CFA, I mean for individual item. When I look at the result, that's a match. So the same thing, I mean, you don't just simply do something that is not right, because people know whether what you present is true or whether what you present is actually not the right thing. All right, so don't mingle with your result, because that will also show the credibility of you as the researcher. Okay, that is what to expect in our topic today. Okay, let's go over the proceed further. Okay, now these are the topic to be discussed. Type of factor analysis, two application for factor analysis, assumption in factor analysis, key terminologies, step in factor analysis, Monte Carlo parallel analysis as an additional method to determine the factors, the number of factors to be extracted, and what next. Okay, that will be what we are going to discuss. Okay, now the two types of, yeah.
Sorry.
Yeah.
Can I ask?
Yeah.
I just want to confirm, I'm sorry if I'm a bit slow, but I just want to confirm my understanding. So factor analysis is an umbrella term, and then under factor analysis, we got EFA, we got CFA, and we got structural equation model, right?
Yes and no. Yes and no. Okay. So, but normally we don't lump these two together under one umbrella. No, we consider this as two separate factor analysis. One is EFA, which is conducted in Spss, and sometimes we call that as just simply factor analysis. And another one is called confirmatory factor analysis, but not done in Spss, but instead we run the analysis in structural equation modeling. I mean, the structural equation modeling is just a procedure in your data analysis, structural equation modeling. I mean, that will be one procedure. I mean, you can use your Spss to run your data analysis, or you can use your structural equation modeling. But when you go for structural equation modeling, you have additional advantages. If you were to compare, if you were to analyze using just Spss. So especially for PhD, I would strongly recommend, if your study is on relationship between variable, your study is on relationship between variable, then a better option is move on to not just Spss, but move on to the brother of Spss, which is Amos, where Amos belong to structural equation modeling. Okay, Nabila?
How
Okay, now we want to, yeah?
Yeah, how that one you suggest to use Amos if it is relationship between variable. How about if we invest in experimental studies?
No, because when we talk about structural equation modeling, focus is more on relationship between variable. But if you are doing conduct research, I mean experiment, for experimental studies, your analysis will be more on comparison. Not so much on relationship, because you want to compare pre-test and post-test. You want to compare between control group and experimental group. I mean, your analysis will be more focused on comparison, not so much on relationship. Therefore, I would say that if you are doing experimental studies, you don't have to use your Amos. You can keep your Amos for other studies later on, but not for that for experiment. Okay. Now we want to discuss the difference between EFA and CFA. EFA is exploratory factor analysis done in Spss, and we do this in the early part after we have done the data preparation. We proceed to EFA in SPSS. Okay, the other one is confirmatory factor analysis, is another purpose where we are we want to confirm whether these are the item that should fall under certain construct, and is this the structure that we can establish based on the research. That means the focus is more on confirmatory. That's why we go for CFA in structural equation modeling. Okay, let's go for the difference. Okay, this EFA, in most cases, we use principal component analysis. I mean, the procedure that we apply for EFA is principal component analysis, or PCA. And we conduct this PCA or EFA in the early part, after we have done the data preparation, we proceed on to this EFA, which is exploratory factor analysis. But what about confirmatory factor analysis? This confirmatory factor analysis is because is done in MOS or in any of the structured equation modeling software, and we want to confirm. We want to confirm based on theory. These are the variable that that can be established to make up the overall model. So we want to confirm, is it true? Or we want to confirm, okay, this is the construct, and these are the items that we use to measure that construct. Is it true? That means that will be the purpose of EFA and CFA. Okay, for EFA, we are concerned on how many factors that we need to extract from the data. How many factors? I mean, when we enter the list of items or indicators into our factor analysis, we want to know how many factors should be extracted. So we remember earlier, we have three methods that we can use in order to determine. One will be Kaiser criterion. Second will be, we can use scree plot. And third will be the Monte Carlo parallel analysis. Or you can also proceed to the fourth method. You yourself as the researcher can force EFA to come out with the set of factors to be extracted. I mean, that it will be the last option. Okay, and then normally we apply this because we want to make sure that whatever that we do, that will give, the result will give more credible to your instrument. And also we develop or we apply this EFA especially to develop new theory, or theory development. Okay, that will be your EFA. For confirmatory factor analysis, we have the factors, but we want to confirm, is it true that these are the factors to be extracted? This the dimension for the factor, and basically the focus here will be, we want to confirm, not to explore, but to confirm whether what we get is matched with theory, matched with what we propose in our study. That will be it. And then, okay, somebody coming in. Okay, then we want to also make sure that whether the item loads on the factors that we have already developed. I mean, let's say now to measure, let's say IV1, we have this set of items. We want to show that this set of items really fall into that construct or into that factor. That is basically when we go for the confirmatory factor analysis. We want to confirm, is it true that this is based on what we propose? Okay, is it true that all these items cling together to that set of factor or variable or construct that we established much earlier? Okay, let's proceed on. Okay, now we proceed to the exploratory factor analysis. Okay, we want to share two different types of factor analysis. One is we want to identify in the item or in our data the underlying factors or structure based on interrelationship between item or indicators. I mean, based on interrelationship between indicators of factor, or item that we have, we want to look for, we want to study what are the patterns, what are the set of factors that will emerge from the analysis. Okay, and then we transform the correlation to between set of we are talking about we want to transform correlation among set of item or indicators into smaller number of underlying factors. I mean, basically, we want to make sure that based on the interrelationship between item, we want to come up with the individual factors that we can establish. These are the set of items that we can use to measure that particular factor, or sometimes we call that as our variable or construct. Okay, it involves relationship between item or factors and the underlying latent factors. I mean, here we are not talking about the what do you call that, manifest variable. Here we are more concerned about latent variable. What is manifest? What is latent? Manifest is observed variable. Latent will be unobserved variable. I mean, when we run our structural equation modeling, we really need to understand about these two type of variable, manifest, which is observed, and then latent, which is unobserved variable. So when you go for this factor analysis, we go for the latent variable, not manifest variable. I mean, we have set of item to measure individual construct. Okay, so in this case, let's say now we have one main construct on environment, and then we have 3 dimensions, and each dimension comprises set of item or indicators. Right? I mean, we run our analysis based on this item here. So the result that we get, we should be able to come out with the dimension or the construct that we can extract from the result of the analysis. Okay, now the two type of factor, the two type of data analysis here will be: one, to explore data for pattern; second will be data reduction. Pattern and data reduction. So what is the difference between these two? So the first one, the pattern is, let's say now you have in your study a set of variable that comprises series of items for each of the variable for your IV and DV, and then we just enter this together in your factor analysis, and we hope that when we get the result will extract the number of factors that will be extracted, matched with the number of instruments that we have in our study. I mean, the number of instrument here refer to the number of variable or construct that you have in your study. Okay, now that will be the pattern. I mean, is it true that that we should be able to get this set of factors, and from the factors that will become your variable or construct, and these are the items that fall under each of the factor or construct. That will be the pattern. Second will be data reduction. Let's say now we have one construct. Let's say maybe we have maybe 15 items. One construct, we have 15 items. But now, if we were to use 15 items, that means it is too much, considered to be too much. Maybe 15, maybe not that many, but let's say you have 20, 30 items to measure one construct. So if you refer to the path diagram, the path diagram will become very what you call elaborate in terms of too many items, right? Too many items in your path diagram. So sometimes maybe it's not that clear, not that clear for you to display each of the construct with the item. So what we need to do will be, from the series of items that you have for that one construct, we want to come up with the dimension of the construct. So let's say we have environment, and we have the 3 dimensions of environment. And then for each dimension, you have the individual set of item or indicators. And that process is called data reduction. I mean, from the initial big number of items for one construct, instead of having only one construct, now we come up with the main construct plus the dimension. And then for each dimension, then you have your item. And then later on, when you go for your structured equation modeling, you can proceed on to what they call as there is one term that you can combine. You can combine this item, just become as if it is just one factor, just one item, just one item. There will be one procedure that you can combine this set of items for each of the dimension. Then you can use that as if you have item 1, item 2, item 3, but actually they are not item, but they are actually dimension of the construct. That process is called, in this case, data reduction. Okay, to make sure that we get a clearer picture I will share you the diagram here. Okay, when you talk about to explore pattern within your data set, so we have, let's say now here we have item A, item 1 to item 5, B, item 1 to item 6, and C, item 1 to item 5. And what you have in mind will be, this will be A item will be construct A, and then construct B, and construct C. I mean, that is what you have in mind. Or if you don't have any idea what is it that it will be derived from the analysis, you just run the analysis. I mean, you will try to look for pattern. But in most cases, we just don't just simply create item, but we create item in relation to each individual construct that you want to study. Right? That will be in reality. So that means in our mind, these are item for construct A, these are item for construct B, these are set of item for construct C. I mean, when you run for your factor analysis, you would expect to have, okay, construct A, construct B, and construct C. That means you have 3 factors to be extracted, and from that 3 factors, you should be able to identify which item fall under construct or factor 1, factor B, and factor C. Right? And that will be pattern. We are talking about pattern. Okay, the second one is we are talking about data reduction. Yes, let's say now we have one construct and it comprises 14 items. Instead of having that's 14 items to measure one construct, you may want to derive or group them into dimension. Maybe set of item measure a dimension 1, another set of item measure the dimension 2 of the construct, and finally a set of item measure dimension 3 of the main construct. Okay, that is what we expect when we run for data reduction. So when we run for the data analysis, what we get will be, let's say, the main dimension, the main construct, and then we have here 3 dimension, and 3 dimension will be your based on the original 14 item. And from here now we have each of the dimension, it has specific item to be used to measure the dimension. So that means your research will become more meaningful rather than just having one main construct. Now you have dimension of the construct. That process is called data reduction. All right. So that means in this case, you have one variable. Earlier we have a series of variable in pattern. You have series of variable, but here you have one variable. But from that one variable, you want to come up with the dimension. That is data reduction. Okay. So any question about the difference between the two? Looking for patterns within your data set as well as for data reduction. Is it clear by now? When you run for your EFA?
Doctor, this is Dora. May I ask for a question?
Yeah, Dora, yeah.
So after we done the data reduction, can we done the item parceling to combine the items under the 3 dimensions, item parceling?
That item parceling is optional. I mean, you can apply that item parceling, or you can retain as what they are. I mean, in this case, you have this is called second order CFA. I mean, in factor structure equation modeling, you consider this as second order factor, second order CFA.
Hierarchical second order analysis, right?
Yes, yes.
So
yes.
we have 2 options. One option is to do the item parceling. The second option is to run the second order stage analysis in
Yes, yes.
Oh, okay.
That will be the option that we can decide when you run for your structural equation modeling. All right. Okay, good. Dora, I mean, you have been exposed to structural equation modeling, and then you can relate here. I mean, when we run for the data analysis, you can go through this first order, or you can, if you want to maintain as first order, that means you have to go through the item parceling. But a second option will be we retain the structure as what they are, but this is called second order CFA. But for those who have no exposure yet on structural equation modeling, don't worry, because we still have ample time to learn and to explore on the structural equation modeling before you start using your SAM for your data analysis. But to me, if it is PhD, it is considered to be near to wajib, near to compulsory for you to learn your SAM, right? Because this is year 2022. in no time will be 2023. And if you still have need more time for your study, maybe you proceed to 2024. So if it is 2020 and above, I would expect at least we learn our structured equation modeling. Whether we want to apply it into our research or not, that is a secondary. But if your study is on correlation, then would be better, because there are some additional advantages when you use your SAM as compared to SPSS for your data analysis. Okay, so we proceed on. So we have here item, the dimension, and the construct, the main construct. Okay, assumption in EFA. Okay, assumption EFA. First assumption is data matrix must have sufficient and substantial correlation. I mean, we have adequate and substantial correlation between items. That is our first assumption. We don't want to have the so-called identity matrix. What is identity matrix? Identity matrix, oh, it's not here. I thought I have incorporated that, or maybe later. Okay, so what is identity matrix? Identity matrix, if you refer to one correlation metric, you have, let's say, x1, x2, x3, x4, and then in the column you have also x1, x3, x1, x2, x3, and x4, and x5 if you have x5. And then if you look at the main diagonal, the principal diagonal, the value will always be 1, is that right? If you refer to the correlation matrix, the value in the diagonal will always be 1. Is that right? Can you visualize?
Yes, Prof. Yes, Prof.
Yeah, actually, this one here, this is your correlation matrix. Yeah, the value in the diagonal will be 1. Why? Because it is a correlation between the same thing. I mean, attitude 1 to attitude 1, of course, perfect relationship. Attitude 2 to attitude 2 will be will also be perfect relationship. But what we want to look for will be the other correlation here, the rest of the correlation coefficient. If all the other correlation coefficient are 0, 0, 0, 0, 0, 0, that means except for the diagonal, the rest are 0, 0, 0, 0, 0, 0, that type of matrix is called identity matrix. So if it is an identity matrix, that means you don't have correlation between items. It is not proper for you to run for EFA. I mean, you cannot actually not proper, but you cannot generate, it will not generate result if you don't have any correlation between items, because the basis for factor analysis will be correlation between items, whether to decide item fall under factor 1, factor 2, or factor 3, depend on interrelationship between items. So that's why the basic assumption will be we have adequate and substantial correlation between item, and the least, the lowest that we can accept will be 0.3. That means anything 0.3 or more. 0.3 or more. That will be the least. But of course, we don't want to have identity matrix. So identity matrix, I mean, all this cell here, where is my mouse? Oh, this cell here. Instead of 0.655, 0.557, 0.705, all this value, the correlation will be 0, 0, 0, 0, 0, 0. I mean, that type of correlation, that type of metric is called identity matrix, right? So identity matrix is not good, but we are lucky in the sense that when we run for the EFA in SPSS, we have one specific statistic that we can use in order to test that our metric is not an identity matrix, right? Which we will, that I have already discussed earlier. Okay, that will be the first assumption. And then the second will be item must be interrelated in one way, since factor analysis seeks the underlying common dimension among the item. I mean, the item to be, the dimension to be developed will be based on interrelationship between items. So that's why we want to have substantial and we have adequate or sufficient correlation between items. The least will be 0.3, 0.3. But even 0.3 is actually considered to be too small, especially when you refer to CFA. If you proceed to CFA in structured equation modeling, what we want is on the average, the correlation and the factor loading that we would accept will be 0.7. We want to be 0.7. Therefore, at this stage, as we can accept at EFA, we go for the minimum 0.3, but in reality, we don't go for 0.3, we go beyond 0.3 in order to make sure that we get a more meaningful and result that we can extract from our factor analysis. Okay, and then the factors or the unobserved or latent variable are assumed to be independent of each other. I mean, when we get the factor 1, factor 2, factor 3, factor 4 from the factor analysis, the expectation is these factors or the construct that we extract from the result should be independent of each other. I mean, they are not measuring the same thing. They are not sharing a lot of common variant. Of course, we should have some form of relationship, but we don't expect the relationship to be high. If it is too high, then we consider it as multi-collinearity, where the result is not good. Okay, and then all item or indicators in the factor analysis must consist of at least an ordinal scale. That means it shouldn't be nominal. The minimum will be ordinal scale, as what we normally have when we go for the Likert scale item. When you go for Likert scale item, then we have 1, 2, 3, 4, 5, or sometimes people use 1 to 7, or sometimes people use 1 to 10, depending on what is the scale that you use. So the minimum will be ordinal scale, but we cannot run factor analysis if it is nominal scale. So ordinal, yes, or you can also go for interval or ratio scale. So that is the type of scale to be accepted in your EFA. Okay, the key terminologies. What is our time now? 3:17. Okay, key terminologies. The first one is communality, which is the total amount of variance and original variable shares with all other item or indicators included in the analysis. I mean, each item we should have the value for the communality from the table. We will share that one afterward, where if we were to add up the total communalities from all the item, and then we should be able to calculate the total amount of variance explained by all the factors that we extract from the analysis. Second will be eigenvalue. We use eigenvalue in many of the statistical analysis, especially when we talk about DCE 6953. Okay, here, when we go for the eigenvalue, we are referring to the sum squared loading for each column. I mean, if we were to get, we are given the factor loading for each of the column, for each of the item. If we was to square that factor loading and then get the total, and that total is the eigenvalue. That eigenvalue is column sum of squared loading for a factor. That means factor for factor 1, factor 2, factor 3, depending on how many factors that you have. So that means in order to calculate the eigenvalue, of course, it's given net spaces output, but will be good for us to share how the values are being derived, so that we can see the operation of how we can operationalize the calculation of the eigenvalue. The same is also true how to get the total variance explained, and then from that commonality, then you should be able to calculate for total variance. And then factor, that means factor will be the linear combination of the item or the indicators that will form one factor, and that will be what we would expect to get from our result for the EFA. Next will be okay, 3-step in factor analysis. The 3 steps are: first, assess appropriateness of data for factor analysis, step number 1. Step number 2, factor extraction. We want to determine how many factors to be extracted. And step number 3 will be factor rotation and interpretation. That will be the 3 steps in factor analysis. Okay, step number 1, the requirement for to check whether it is appropriate for your data for factor analysis. So first of all, we look in terms of sample size. Okay, according to Tabachnik and Fiedel 1996, the minimum number of cases, or N, for you to run for your EFA is 300. That will be what is suggested by Tabachnik and Fiedel. Minimum is 300. Because it have to be big, right? Or you can use the criteria given by Nunnally, 1978. Recommend for 10 to 1. I mean, 10 cases to 1 item. I mean, if let's say you have 20 items, then you need to have 200 cases, or n equal to 100. Okay, the bare minimum, according to literature, 5 to 1. That means 5 cases to 1 item. That means if they say you have 20 items multiplied by 5, I mean you need to have 100 cases. That will be the guideline that we can use in order to determine the sample size. But of course, when we run for our when we run for our SPSS, and then when we get the result, we should be able to get the result for the test on the adequacy for sampling, whether we have adequate sample size to run for this EFA. And then the strength of inter-item correlation, as mentioned earlier, are to be more than 0.3. 0.3 or more. That will be the minimum to be accepted. Okay, in your SPSS, the first statistic given is Kaiser, Meyer, Olkin. But this option, this statistic is option. I mean, if you don't tick the option, you will not be getting the result. So make sure after that, I will share with you, afterward, I will share with you which option that we need to click in order to get the Kaiser, Meyer, Olkin, or simply the short form KMO. What is KMO? It's a measure of sampling adequacy. Okay, and the value for your KMO ranges between 0 to 1. The value for your KMO ranges between 0 to 1. And then according to Tabachnik and Fiedel 2013, the minimum value for KMO is 0.6. Is 0.6. I mean, to be considered to have adequate sample size for you to run for your EFA. But generally, the cutoff point that is applied will be 0.7. I mean, just like your Cronbach alpha, we want to have 0.7 onwards, right? So in this case, of course, Tabachnik suggests for minimum 0.6, but conventionally, 0.7 is more acceptable to be used as the cutoff point to test for sampling adequacy based on KMO. If your KMO is less than 0.5, then the result will not be that useful. Therefore, you may abandon using your EFA, proceed on to your SAM, and then proceed to CFA. Right? That is the option. Okay, next, the second statistic is Bartlett test of sphericity. Oh, what happened? You go to the last slide. That's my mouse. Okay, this is the mouse. Okay, where are we now? Just now. Okay, here we are here. Coming back to that. Is that slide on the screen now? SPSS test
yes.
For okay, that will be okay. Good. Okay, that will be the first statistic MO. Okay, and you have here another criteria given by Hutchison, 1999, where if it is 0.5 to 0.7 considered as moderate, for moderate sampling size or sampling adequacy, 0.7 to 0.8 considered to be good, 0.8 to 0.9 considered to be very good, and more than 0.9 will be excellent. I mean, you have excellent sample size for EFA. Okay, next, Bartlett test for Sparicity. Okay, Bartlett test for Sparicity. So this is just to test whether, to make sure that you don't have the identity matrix as shown here. This is our identity matrix. The principal diagonal, we have 1. The rest will be 0. That is identity matrix. So to make sure that it is not an identity matrix, what we want is a significant result for Bartlett test for Sphericity. I mean, we want to make sure that the significant value for the Bartlett test for Sphericity must be less than 0.5. I mean, if your alpha is 0.05, we want to make sure that it is significant. When is the case it is significant? When the significant value for the buttered test for sphericity to be less than 0.5. Okay, that is what we need to expect in order to make sure that our metric is not identity matrix, and we have adequate and sufficient correlation between items. That is the second statistic that we can use in order to test for sampling adequacy, KMO, and buttered test for sphericity to test for sampling adequacy, for the identity matrix. Okay, okay, next. Factor extraction. Okay, this is the second second step, factor extraction. So we have, what we want is when we go through this factor analysis, the procedure that we apply is principal component analysis. We want to have smaller and meaningful number of factors to be extracted, so that if as much as possible, it matches with what you propose in your framework and what you propose as embedded in your instrument. Right? Simple solution with few factors, and as much as possible, it explains larger number or a larger percentage of variant. That is what we expect. And we have three procedures that we can select or that we can choose. By default, the SPSS use the Kaiser criterion, which is eigenvalue more than 1, or you can also choose for script plot. You can also option for script plot as another method to determine the number of factors to be extracted, or you can use the Monte Carlo parallel analysis. But this Monte Carlo parallel analysis is not embedded in SPSS, but we have to go to the website, download, and you can incorporate that command into your SPSS syntax editor for the analysis. Okay, for Kaiser criterion, we just need to focus on this initial eigenvalue. You see the first column here. The first column is initial eigenvalue. Focus your attention to the column called total. I mean, we look for if the value is if the value for the eigenvalue. I mean, these are eigenvalue. If the value are more than 1, then you should be able to extract that as a factor. I mean, in this case, the first value for the eigen is 3.839. I mean, you get first factor. The second value for the eigen is 2.150. I mean, you get second factor. But when you go to the third component, the eigenvalue is less than 1, is that 0.917, less than 1. Therefore, based on this, based on the Kaiser criterion, only 2 factors will be extracted from this analysis. Based on the result, only 2 factors will be extracted because the criteria is eigenvalue more than 1. If it is less than 1, it will not be considered as a factor from your SPSS factor analysis. Okay, that will be the first method in order to determine the number of factors to be extracted. Second will be script plot, Cartel script plot. So that means if you were to request for the Cartel script plot, then we look at the point. Now these are the eigenvalue, the value for the value for eigen for each of the factor. Okay, you look for the point at which it starts to level off. I mean, this is steep slope, but starting from here, it starts to level off, is it right? That means the number of factors to be extracted will be based on the one before and then the corresponding. I mean, the one before it starts to level off. Therefore, in this case, the number of factors to be extracted will be 1, 2, 3, because it starts to level off here. But you don't include this as one factor, but we just count the number of factors before that. So that means in this case, 1, 2, 3 factors to be extracted. Now that will be based on script plot. But this script plot, you need to tick the option in order to get the result. Okay. Next will be Monte Carlo parallel analysis. So what you need to do will be, you go to this website. This is the URL, long URL, is that right? Once you click on this, and then it will go to the web page. And then what you need to do will be, on that page, look for, since we are using SPSS, under SPSS, look for raw.sps, raw.sps. I mean, we just need to click on that, open that up in the file. When you open that file, then Right? You copy, just click the right button and then select all and then copy. And then we go to the Spss syntax editor and then just paste that command into our Spss syntax editor. And then what we need to do, we don't run yet. The next step will be we need to delete set of command. I mean, you look for, there is a star here, start of artificial data command until star end of artificial data command. I mean, you can look at the line, I mean here, line 58 to line 79. I mean, the command include start artificial data command until end of artificial data command. I mean, we just highlight this and delete. That will be, after we have pasted the command, we look for this set of command and then delete. The next step, we look for this specific command here, roughly line 70. Okay, you just need to change, instead of var1, var1 to var9, that this is based on the example given, but you just need to substitute your variable name, the variable name in your study. So just identify the first item and then to the last item. Okay, that the first thing that you need to change. And then under compute and that sets equal 100, we just change that to 1000. I mean, we add another 0. I mean, instead of 100, we change that to 1000. Okay, so that will be the two changes that we need to do. Change your name of variable and then change from 100 to 1000. And then after that, what you need to do will be, we just click on run and then click on all. I mean, we run all. Or you can just simply highlight all and then run selection. Either method will be acceptable. So that means when you run this procedure in Spss using the command that we copied from that website, you should be able to get the result. And the result will be something like this. The result will be here. I mean, what we need to look for will be, look at the raw data. The raw data will be the actual eigenvalue. And we compare that against the mean here refer to the 50th percentile, but we want to refer to the percentile here. And percentile here refer to the 95% percentile here, the percentile, yeah, 95th percentile. Okay, that means we refer to these two columns, the second column and the third column. Raw data against percentile, right? Raw data against percentile. The criteria will be, if the value for the raw eigenvalue bigger than the percentile, then you will consider that as one factor. So in this case, in this example, the first factor, I mean, under the root here, the first factor here, raw is 3.8, percentile is 1.34. Since this is bigger than this, that means you have factor 1. Okay, when you go to the second line, the second potential factor, okay, the raw eigenvalue is 2.149. The percentile is 1.25, also bigger, is it right? So that means the second factor will be extracted. But when you go to the third line, the raw is 0.917 and the percentile is 1.1889, is it right? Okay, that means your raw is smaller than the percentile, therefore that will not considered to be a factor to be extracted. Therefore, we just stop at only 2 factors to be extracted. So the criteria will be the raw eigenvalue under the column for raw data must be bigger than the percentile column. If the value for the raw data is bigger than the percentile, then that factor will be extracted. Okay, that will be what we intend to do afterward in the second session. And then next will be factor rotation and interpretation. So we will be using the orthogonal method, which is the uncorrelated, and the specific method to be applied is varimax, in order to make sure that we get a more meaningful and easy to interpret result. So we go for the orthogonal method, the uncorrelated, and specifically we go for varimax. So in this case, we just need to tick this option here, you see, varimax, and then just click on continue. All right, continue. And then, of course, if you want to go for the oblique, which is the correlated method, then we can go for direct oblimin in Spss. Okay, for the Spss procedure, we will work on that afterward, after break. So for now, I open for if there is any question for clarification, please. You get better idea now about what to expect for factor analysis. Okay, question?
Prof.
Yeah.
Here. Prof, I have a question. For master's level, would it be sufficient if we just do until the first step, which is to match the total number of factors to extract, and then if it corresponds to the IV and DV that we have set, will that be enough, or we have to continue with everything if once we have started?
Okay. If we are referring to the step that we need to proceed in EFA, I mean, we need to follow through until from the beginning until the end, from beginning until the end, not just to say that okay, these are the items, but we want to make sure that we check whether we have adequate sample size. We want to check whether our data is not up in the identity matrix, and we want to start with first of all determine number of factors to be extracted, and then we proceed on to factor rotation, and then we proceed on the no, the first one is we look for the check whether it meet the criteria for factor analysis. Second is factor rotation, and the second is to determine number of factors, and then third will be factor rotation. Right? And I mean we need to follow through the step as such, complete until what next? What next? We complete until that step. That is what is expected, regardless whether you are doing your master's or PhD. Because that is embedded as part and parcel of the process for EFA. Does that answer your question, Yogasri?
Yes, Prof.
Okay. Others? Any question?
Yes, Prof. Thank you.
Okay, welcome. Yeah.
The whole sequence of the step just now is for the one that developed a model, right? I just want to make sure.
Yeah, of course. I mean, remember earlier when we distinguish between CFA and EFA. EFA is more towards developing, building theory or model. I mean, that's why we have to go through that step, right? But when you go for CFA, that means confirm. That means we want to confirm whether what we get mesh with what the literature or the theory have to say. So here we want to come up with something new, right?
Okay, so like in the last lecture last week, when you see that, for example, if we want to check for validity, we use SAM. So we use CFA, right, rather than EFA.
And I mean that will be after you have done for your EFA, then we proceed to CFA. After I mean the step will be like this. First of all, you got your data, right? You get your data. Once you get your data from your questionnaire or whatever data collection, the next step will be we follow through the data preparation step, which include that 7 procedure. But we incorporate the data screening instead of just run frequency. We incorporate into data screening in that data preparation. After we have done the data preparation, including the data screening, which include the case screening and as well as variable screening. And then we proceed to EFA, where when we proceed to EFA, we want to make sure that the item that we propose to measure certain construct really based on statistical analysis, in this case EFA, will fall into the corresponding construct or factors. Right? And then after we have done this, then the next step will be if you intend to use structural equation modeling, then we go for CFA, or maybe you just use structural equation modeling for CFA, and then after that you go back to Spss to run for your data analysis. But if you have done your CFA in structural equation modeling, my option will be, why not continue with your structural equation modeling? Then you don't have to go back to Spss, right, Nabila?
But just now you said if I'm doing experimental, I cannot use SAM, right?
Of course, you do not do because the nature of your research doesn't require for a relationship between variable. Therefore, you just stop at EFA, whereby you want to make sure that if you have that construct. But in most cases, if your study is more technical in nature, you don't have to go for EFA because you are measuring a certain variable using certain instrument, not the item, but specific instrument. Example, we use thermometer to measure temperature. We use weighing machine to measure. I mean, just easy to think what instrument. If you are in physical sciences, but if we in the social sciences, our variable are conceptual in nature. Therefore, we need to go through the CFA, and then if your study correlation in nature, we proceed to CFA, and then proceed to measurement model, and then proceed to the final stage, structural model. Okay, I have a question.
1, 2, 3, that is the conversion and discriminant validity put in chapter 3, right?
Chapter 3 will include result for CFA and your measurement model, which also include your convergent validity, construct validity, convergent validity, discriminant validity, construct reliability will be just presented in chapter 3.
Okay, thank you.
If you are not, your study is not to develop instrument, then the normal instrument, we just want to measure our construct, that will be what we expect you to present the result into chapter 3, not chapter 4, because these are just data preparation. Okay, Anders? Our time now is...
Prof?
Yeah.
So we have 3 methods to determine number of factors extracted.
Okay,
so we should use only one or all of the 3.
Okay. Okay, remember, this will be your research. This will be the data analysis that you want to work on your research data. So my advice will be to make sure that we get a more credible number of factors to be extracted. Try on all the 3. Use the first criteria, which is based on eigenvalue more than 1. How many factors to be extracted? Based on skill plot, how many factors to be extracted? Based on Monte Carlo, how many factors to be extracted? That means you have a better basis to make your decision on how many factors to be extracted. That means that will be more credible. But of course, when you want to write into your thesis, you can just explain. No need to elaborate very detailed, but just explain based on the 3 procedures. Then the number of factors extracted will be this, and this is the justification. Right, Malay? Does that answer your question?
Yeah, yes.
Okay, good.
Yes, Prof.
All right.
But
okay.
The website, in our notes cannot be opened, cannot be entered.
Okay.
Cannot be,
I just may want to try because I have been using that website for many semesters before. So otherwise, maybe the website is down for the moment. Otherwise, we should be able to access. So far, we should be able to access. But if we don't get it there, then I will share the one that I have already downloaded from the website. So initially, we try to get to access the website when we go for the hands-on after break, inshallah. Okay, others? Maybe we have 2 more minutes before we take our break. Yeah.
Prof, I have 2 questions.
Okay, oh no. Sebab tu dia diam dulu sebab dia ada kumpulkan 2. Okay, soalan pertama.
My first question, can we run EFA using pilot test data?
Okay, first question. Second question.
And my second question, let's say if our data is not normal, can we run EFA and CFA? Thank you.
Okay. Question number 1. Can we run EFA on pilot study data? Okay, to answer that question, in most cases, for our pilot study, we don't normally go for big sample size. Right? Normally, what is recommended, maybe you just get about 30 cases will be suffice for your pilot study. So being too small might not be a good idea for you to run for your EFA. based on your pilot study. I mean, for your pilot study, maybe you just want to check whether the instrument is okay and the reliability is okay. I mean, you just check of that nature, not to run for your EFA. And then what happens if your data is not normal? Okay, regardless whether normal or normal, no problem for you to run for your EFA, because after all, at this stage, we don't care about the distribution for your data, whether normal or not normal. But later on, if you proceed to your structural equation modeling, especially if you are using covariant-based SAM. If you are using covariant-based SAM, you have two types of SAM. One is covariant-based, the other one is variant-based. Okay, the first category, which is covariant-based, include MOS, include most of the other packages for structural equation modeling. But which one under the second category, which is variant-based? Variant-based is Smart PLS. Smart PLS fall under the second category, which is the variant-based SAM. So for variant-based covariant-based SAM, example, we are using MOS, it is a parametric statistic. Being parametric statistic, that means we need to check on the assumption of normality. But normally we check the assumption of normality, not in the first stage, which is CFA, but we check in measurement model, stage number 2. When we run for measurement model, then we check for the assumption of normality. Right? Okay, that means we need to check that. So whether it meet or not, but as much as possible, we want to make sure it meet the assumption, because this is parametric statistic. And that means we don't need to worry for EFA, but in your second stage in your structural equation modeling, when we run for measurement model, yes, we need to check. Why we need to check for the assumption of normality? Because this covariant-based SAM is considered as parametric statistic. And then we can test using skewness and kurtosis based on the given output from MOS. That one will be discussed if you attend for any workshop on structural equation modeling. By the way, Faiza, have you attended any workshop on SAM yet? You are doing your PhD, is that right?
I attended Zainuddin's course last year.
Oh, last year. Oh, by now, last year,
Zainuddin.
at least in a few months back, is that right? I mean, we hope that.
So originally, I planned to do model development, but then my SV asked me to change to instrument development.
Instrument development, okay. Well,
Yeah,
instrument development, you still can
SAM,
apply. You can still use SAM, but we just follow
for
the
construct
first two
validity.
steps. Pardon me?
For construct validity, I can use SAM, right, Rota?
Yeah, that means we can just proceed only 2 stages. Stage 1, CFA, and measurement model, full stop. If you are developing instrument. I mean, you can still use your, I mean, by the time you want to use your SAM, since you have already attended the Abini workshop, we hope that you can apply the knowledge and the skill that you have learned into practice. But the keyword will be practice. you cannot just put the material on one side and you place your folder to the last folder. That means Z1 or Z2. Then if you put it somewhere like that, then the tendency is by the time you want to use your SAM, you have big question mark. So practice is the keyword. Right. So did Prof siapa tadi?
Prof Zainuddin.
Did Prof Zainuddin share?
I just attend
stages for SAM analysis.
I just attend the basic because I want to get to know SAM first.
Did he mention about the 3? Did he mention about the 3 stages in SAM analysis?
Yes, he did mention.
That will be good enough, inshallah.
But then my SV asked me to use Rush model instead.
Yeah, you can use also Rush model, but in addition to that, also you can use the SAM to check for the convergent as well. Because I've seen candidate for where they develop instrument, they use both. They use a Rush model as well as they use SAM. But SAM only the first 2 stages, no need to proceed to stage number 3, which is structural model. Okay, others? Otherwise, okay, oh, mashallah, now it's already 3:50. Okay, let's take our break and we come back at 4:05. Then we take 15-minute break. We come back at 4:05. And for the Muslim, be careful. There will be no refreshment during break. You just take a rest, take a break, but no refreshment. But for the rest, of course, you can proceed as usual or with your refreshment. Maybe refreshment is already ready, or you can wait in the waiting room. Maybe in the waiting room, in your waiting room, the refreshment is ready. Your spouse has been get the refreshment ready, but not for us because we are still fasting. Inshallah. Okay, we come back at 4:05. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Prof. See you.
You're welcome.
Prof,
Yeah.
Prof,
Yeah. Ada soalan?
can I just ask you something?
Yeah.
Because my other lecturer told me that for to check relationship on moderating variable, you can also use macro process. Is that under SPSS? What's
Okay.
that, Prof?
You are testing for mediating variable, is it right? Mediating.
Moderating.
Or moderating.
Moderate.
Okay.
Moderating.
You may want to consider using the procedure called process. Have you heard about process? Okay, you download from the internet an apps called process. You can install into your Spss and it become one of the option in the menu for your analysis. When you click on analyze, click on regression, you have an option for that process. When you install that into your Spss, I mean, if I'm not mistaken, for sure you can run for mediation, simple mediation. Maybe also it can also be used to run for moderation effect. Yes, maybe. Right? But
Thank you, I'll check that.
why don't you go to structured equation modeling? Okay, even though you're doing your masters, yeah, right? It's not.
Yeah, I'm so scared, Prof.
That was what I thought last time. Structural equation modeling seems to be big name, seems to be very complicated, but it is as simple as ABC. I mean, if you know how to draw, and we are not talking about artistic drawing. We are just talking about, do you know how to draw a rectangle? Of course, yes. If you do know how to draw an oval shaped object, yes. Do you know how to draw a single line, one arrow headline? Yes. Do you know how to draw a curved double arrow headline? Yes. I mean, everyone, without exception, should be able to work on SAM. So the name seems to be complicated, but in reality, used to be very complex, because last time I still remember when I did my PhD together with one of my friends in UPM, we went together the same flight to study our PhD, the same university. She used at that time SAM for her data analysis, but that time the SAM that they have under Listral, called a software called Listral, it was not as easy as what we have now, user-friendly, not just user-friendly as what we have now. That last time, if you don't have any knowledge and skill in using computer language, forget about SAM. Unless if somebody were to help you to run the analysis, otherwise it is quite impossible for laymen like us to run for structured equation modeling, because it is not as user-friendly as what we have now. But now, if you know how to draw, everyone should be able to work on your SAM. And then if you have been exposed now at your masters for your SAM, later on, of course, that was also what we thought, what I thought last time. If I manage to complete my bachelor degree, that's it. It should be enough for me. But after we graduate our BS, after some, we are ready for our masters. Okay, maybe after masters, I think maybe that's it. That will be enough for me. But after we complete our masters, now we are ready for PhD. So that means if you were to pursue for your PhD, then you are more prepared, because why? You have the tool, right? I mean, for graduate student, if you can master this tool, that will facilitate your study. What are the tools? One will be reference manager. Second will be statistical analysis tool. If you get this tool handy, then your process in completing your master's PhD will be as easy as ABC, inshallah. Okay, Yasri, of course you can use your the process, but maybe invest a little bit and then learn and then apply. The skill that you need to know is just how to draw object. That's it. Okay, does that answer your question, Yasri?
Yes,
So my
Dr.
challenge to you, Yasri, learn your. Who is your supervisor? By the way, who is your supervisor?
Prof is me.
Oh, Prof is me. Okay, I will inform Prof is me. I will inform that your Gasri is ever now ready to learn SAM, because she wants to pursue data analysis using SAM for the moderating effect. And then later on, after her master's, she will continue for her PhD, inshallah. Okay, I'm sure Dr. Ismi, Prof Ismi will be glad to hear that. Okay, I'm just kidding. I'm not talking. Okay, others, if you have any question. Otherwise, we proceed for the hands-on. The hands-on on how to run the EFA using SPSS. Okay, let me. Oh, I already opened this software just now. Okay, so let me just minimize this. Okay. Okay, in the first place, let's try to access the website. Malik, did you manage to access the website just now?
Not just now, maybe yesterday. But
oh, yesterday. Okay, try now. Try now. Good. You have browsed through the material. Okay, let me try to copy this. Okay. Everyone try to open the website. Oh. I still cannot open it. Anybody can open? I try to open, but it seems it doesn't cannot open.
Prof, I sent a link. Maybe it's okay.
Huh?
I found it.
Oh, you can access? Okay, let me try again.
Yeah.
Okay, let me try again.
Try access again, Prof.
Oh, yeah? Okay, let me open. Okay, let me try.
The link have include in chat.
We use link in the chat.
Because if I can access, then I can guide through the procedure. Okay. So the rest can open the website, the link. Male, could you access?
Yes, Prof.
Okay. Oh,
with the link.
I
now
am the only one who can access the link. Okay, let
Prof,
me try.
there is a link in our chat box.
Pardon me?
There is a link in our chat box.
Okay, let me try.
I already put the link in chat, Prof.
Only in chat. Okay, let me try it. Yeah. Okay. Is the chat?
In Zoom chat.
Yeah. Okay. I'll try to access. Maybe something wrong with the. Okay, if you can access the page, what you need to do will be you go to the title Spss and then open the raw par.sps. Open that document. Okay, open
Maybe
that
you
document.
can try a new link in chat, Prof.
Okay, try to paste in the in our WhatsApp group, because I don't know why I click on the chat, it doesn't open. So try to paste in the WhatsApp group. Okay. Oh, the link is straight to the document, right?
Yes, Prof.
Okay,
Yes.
so what you need
Yes,
to do will
Prof.
be, okay, copy the whole thing, the whole list of command. Okay, copy, and then okay, now let me open my SPSS and I open my this new syntax. Okay, you just click on File, New Syntax. Okay, and then in the meantime, I will share the syntax dialog box. Okay, open your syntax editor. Everyone, have you opened your syntax editor? Okay, we have already copied the command and then paste into the syntax editor. Paste into syntax editor. Okay, have you pasted that into syntax editor?
And Prof.
Okay, now look for the line that start of artificial data comments, artificial data comment, roughly line 58 accordingly. Line 58. Here, start artificial data comment, line 58. Okay, highlight until end of artificial data comment. Highlight that, and then delete, remove that. Remove that set of highlighted comment, delete. Okay, and then after this, we will change the variable name And after this, we will change from 100 to 1000, just below that. Okay. Okay, so we get this one ready first. Okay, now let's go for the step-by-step procedure. Go back. Okay, now we go to the what? Okay. Okay, what do you see on the screen currently? Is it variable view from Spss?
Yes, Prof.
Okay, so in this case, we are going to use this one factor. No, I didn't share this data set with you yet. Is this the data set? Yeah, I didn't share it. Okay, let me share this data set to through our WhatsApp group. WhatsApp. Oh, I want to share the data set just now, mashallah. Okay, let me work on that. 5950 6953. Oh, so this afternoon seems to be something not right. Okay, there is one technical error here. What is it? Okay, we are going to use another. Did I share that data set 5950 6953 factor analysis?
No, Prof.
No, yeah.
No.
By right, I should have shared that one. Okay, let me try.
Prof, just take your time, no worries.
Yeah, but, but I tried to attach the file, but when I click on the attachment link, it doesn't work. I don't know why.
Is it because now you are opening the file?
Pardon me?
Maybe is it because now you are opening the file? Maybe you should close the file first, then you click share the file into our WhatsApp group.
Yeah, okay, wait, I will try to look into.
It's okay, take your time.
All right, thanks.
Oh, maybe Prof just drag and drop from file to drop to WhatsApp group. So okay.
Dia boleh ke?
Boleh.
Does it
Ambil
look that
file tu
way?
tarik. Daripada file tu tarik
Masuk ke WhatsApp group je. Okay, let me try. Okay, let me try.
Okay.
Data set. Okay, in the meantime, now is Azan, so we will take a short break.
Okay, Prof.
Yeah, all right.
Okay, Prof, no problem.
Okay, it's done. So open your WhatsApp group, our WhatsApp group, and then download that data set.
Okay, Prof, done.
Okay. Okay, that is the data set that we're going to apply for this analysis. Okay, now open that data set.
Prof, can you just kindly forward that to sit-in group?
Oh yeah, yeah. The sit-in group. Oh,
Already.
Already
Yeah,
done?
already.
Okay,
Yes, already done.
Okay, thank you.
Ada rakan.
Ridru, thank you, Ridru.
How is it possible that you share with the sit-in group? Are you in both group? By right, one student should be only either in the registered or in the sit-in, right?
Ridwan is class principal, Prof.
Huh? Class principal?
Because he always give useful information.
But are you registered or sit-in? Our friend just now. Sit-in.
I only sit-in.
If you are sit-in, make sure you are not in the registered group. Yeah. Because next time for purposes of exam dan sebagainya so awal-awal saya dah buat begitu. So make sure left the registered group, just maintain in the But anyhow, thank you very much for helping to share to the sit-in group. But if you are sit-in, but you shouldn't be in the registered list or in the registered WhatsApp group. Yeah, kalau boleh just leave from that group and then just retain in the sit-in. Yeah. Siapa ni tadi? Who is it? Who is the one yang in both group tadi tu?
Saya, Prof.
Siapa tu?
Okay.
Siapa?
Ridwan.
Oh, Rizwan. Okay, Rizwan jadi Rizwan kena keluar daripada yang registered group tu. Just retain dalam meja. Sebab itu saya wonder how is it possible that dia ada access dua-dua? Sepatutnya dalam satu group je. Ya. Sorry because for untuk urusan-urusan yang lainnya jadi kita have two separate group. Ya. Okay, so now we have already opened the data set. Okay, so now let me check. Ridwan dia lebih hebat lagi. Okay, tapi hari ni I wonder why it doesn't have if we have, okay, tak apalah, kita biar dulu. Okay, now coming back. So let me share the who are the Spss. Okay, this is the data set that we're going to apply for our EFA, Exploratory Factor Analysis. Okay, now the first step will be we want to check for the adequacy for sample size, as well as that we don't have the identity matrix. Okay, so the procedure will be we click on Analyze. In order to run for this analysis, we click on Analyze. We click on Dimension Reduction, and then click on Factor. So Analyze, Dimension Reduction, Factor. Once you click on Factor, then we just the item to be analyzed will be V1 to V12. These are the list of item that we want to run for factor analysis, V1 to V12. And then the next step, click on descriptive. This is the option in order to get the KMO as well as Bartlett test for sphericity. So click on the descriptive and then tick this option, KMO and Bartlett test of sphericity. Okay, tick that only one option. The rest might not be important. Okay, are we done?
Done.
Okay, click on continue. Okay, next click on extraction. Extraction, and then by default, you are given eigenvalue more than 1. That is the criteria that we use, the first default criteria. And then in addition to that, we also want to request for scree plot. Okay, click on scree plot. And then click on continue. The one that I mentioned, the fourth option is if you want to force factor analysis to provide or to derive the number of factors, is here. I mean, you can take this option, fixed number of factors. I mean, you can enter the number of factors here. I mean, this is you as the researcher will decide on how many factors that you want. But in most cases, we don't apply that, but we apply the Kaiser criterion, as well as we choose for scree plot. And after this, we also will run through the Monte Carlo parallel analysis in order to also help us to determine how many factors to be extracted. So in this case, if we are done, click on continue, and then rotation. Click on rotation. By default is none. That means none of the option is selected. So we go for the orthogonal and we choose Varimax. We choose Varimax. If we are done, click on continue. And then, okay, in the first round, we don't click on the option, but we look at the result. But when we look at the result, it's not that informative. So after this, I will share to select for option. But currently, we don't click any option yet, the option button. But after later on, I will share which option that we need to select in order to get more meaningful and easy to observe for the result. So, okay, for now, if you are done, then simply click on OK. Okay, everyone. Are you still with me? Could you follow me? Anybody left somewhere? Okay, good.
Yes.
So after all, bus is currently moving at the speed of 35 km/h. So we hope that no one left by the bus, and everyone reached to this point. So simply click OK. When we click OK, then we open our SPSS viewer. Please open your SPSS viewer. By default, yours is open automatically, but I need to change to our SPSS viewer. Okay. The first table given to you is KMO and Bartlett test of Sphericity. This table here. Right? If you refer to this table, okay, maybe I change the. Okay. You can see clearly. Okay, I'm now referring to the KMO and Bartlett test of Sphericity. Okay, we look at KMO. What is KMO for? Anybody can recall what is the purpose of KMO?
Some sample size, adequate sample size.
Mentioned here, Kaiser-Meyer-Olkin measures of sampling adequacy. Okay, so by convention, we want the value to be 0.7, right? 0.6 was what is suggested by that author just now. But most of the time, we use the criteria 0.7. So in this case, what we get for the KMO is 0.827. So what can we say? What can we conclude? Do we have enough sample for this study, for this analysis?
Adequate.
Yes, because 0.827 is more than 0.7. Therefore, we have adequate sample size to run for EFA. Okay, that will be the first test given for the option earlier that we take. The second test is Bartlett test of Sphericity, where we are testing that we don't have our metric is not an identity matrix, but we have adequate and sufficient correlation among item. So in order to test for this, in order to test that it is not an identity matrix, the criteria that we use is make sure the Bartlett test of Sphericity must be significant. How to show that it is significant? We just simply look at the significant value for chi-square, if under chi-square. Make sure the value is less than alpha. In most cases, we use alpha 0.05, is it right? So in this case, our significant value is 0.000, and it is smaller than alpha, is it right?
Yes.
Yes, Prof. It's less than
Just a moment, apa ni, ada somebody.
Sorry, just now proceed less than 0.05 or 0.5?
0.05. Actually, that is our alpha value. It could be also 0.01, but for social sciences, we often use 0.05.
Okay, thank you, Dora.
Welcome.
Dora, I just want to confirm. So since the approximate chi-square is 1507 and it is more than 0.05, means that it's not significant, is it?
No. You look for the value, significant value.
Okay.
It's
0.000.
Yes, correct. That
Okay.
is the significance value. It is, I think, in the fourth row.
Okay. Thank you. So we are not looking at the approximate chi-square because just now I heard he mentioned we look at somewhere at chi-square.
We look the significance value of the approximated chi-square test.
Okay, all right. Noted.
Okay.
Thank you.
Welcome.
Hello, Dora.
Yes.
Dora.
Yes.
Sorry. I just now I missed. I can't find the data right now. And could you tell me where can I find the data? Where can I get the data, please? Thank you.
In our WhatsApp group.
WhatsApp group?
Yeah, WhatsApp group.
And
WhatsApp group.
Yeah, here I can find 3 links. And which one is the data?
Send it to you.
WhatsApp.
Sorry,
WhatsApp group.
Yeah, in our WhatsApp group.
And here in our chat box, I can find. Sorry, WhatsApp group. Sorry. Yes, can find it. Thank you.
Welcome.
Hi, can someone help
Okay,
me
okay,
from
sorry.
data editor?
Itulah bila kelas kat rumah ni tu jadinya. Sometimes interruption tapi ni. Okay, coming back. Okay, now based on that two statistics called KMO, which is Kaiser-Meyer-Olkin, as well as Bartlett test of sphericity, what you can say is we have adequate sample size, and we don't have. I mean, our metric is not an identity metric. So basically, we have adequate and sufficient correlation between or among the item or indicators. Okay, that will be the first one. The second table that we are given here will be commonalities, which we will be discussed. That one, which we will use this in order to calculate the percentage of variance. But what we want to see here will be the how many factors to be extracted. Okay, refer to the table titled Total Variance Explained. Focus your attention to total variance explained. Okay, as what I have shown you earlier, look under initial eigenvalues. I mean, the column for initial eigenvalues, you have total, percentage variance, and cumulative, right? Initial eigenvalue. Okay, now the criteria says based on the eigenvalue more than one, which is Kaiser criterion. So we look for the value for eigenvalue that is more than one. Eigenvalue more than one, that are the number of factors to be extracted. So in this case, 1, 2, is that right? I mean, we have factor 1, we have factor 2. But I mean here, the component here refer to number of items that we have in our analysis. So we have 12 items just now. So we have factor 1, we also have factor 2, but when we proceed to factor 3, the initial eigenvalue is now less than 1. Therefore, based on the first criteria, which is the default criteria, Kaiser criterion, eigenvalue more than 1, only 2 factors will be extracted. Okay, that is the first method. The second method, we look, since we have already ticked the option for scree plot. Okay, this is the first eigenvalue, the second eigenvalue, the third eigenvalue. What we can see, this is very steep, is that right? Steep slope, another steep slope. But starting from here, from the third point, it starts to level off, is that right? So that means in this case, we just count the number of points that is prior to that when it starts to level off. So we have 1, 2. I mean, based on scree plot, we also should extract only 2 factors. So based on Kaiser criterion, 2 factors. Based on scree plot, 2 factors. Okay, now we are ready to work on the third method, which is the Monte Carlo parallel analysis. Okay, now in order to run for Monte Carlo parallel analysis, tutup. Gunakan yang kunci. Okay, now in order to use the third method, this which is Monte Carlo. Now please open the Spss syntax editor, the one that we have copied the command just now. So please open syntax editor, close this. Let me
sorry, question.
Pardon me?
Can I ask question about the eigenvalue one just now? So we have
the scree plot. Are you referring to the scree plot?
Yeah, the total variance explained. We see the component and the scree plot. There's 2 components that have eigenvalue more than 1, right?
Yeah. Okay. Let me post you the result just now. Let me share.
So means that only these 2 components will be extracted or not extracted?
Extracted. I mean only two factors will be extracted. Factors relate to component 1 and component 2. I mean, based on the criteria for eigenvalue more than 1, only 2 factors will be extracted. Why? Because if you look at the first eigenvalue, more than 1. The second eigenvalue, more than 1. But the third eigenvalue is less than 1. Therefore, we only extract 2 factors.
Okay. So extracted means that is only will be counted. What does extracted means here?
Extracted, I mean, how many factors are we going to get from this analysis?
Oh, okay. All right.
Okay.
Doctor, can you explain the diagram of the scree plot?
Okay, scree plot. Okay, let me go back to the scree plot. Okay, this is our scree plot. So this is the second method to determine the how many factors to be extracted, how many factors that we will be getting from the analysis, from the result for this factor analysis. So now this point here refer to the value for eigenvalue. Okay, the first eigenvalue, let's refer to the first eigenvalue, 3.839, right? 3.839, the first eigenvalue.
Yes.
The second eigenvalue is 2.1550, 2.150. And the third eigenvalue is 0.917, 0.917. I mean, each point here refer to the eigenvalue. I mean, how many points that we have? Since we have 12 factors and 12 indicators or item, so we have 12 component, and also we have 12 dot. 1, 2, 3, 4, 5, and the 12 is this one. That correspond to how many items that we have in our data set, in our analysis. Okay, in this case, what we need to look for is, look for the point at which it starts to level off. Which point it starts to level off? Is it the first point? No, because the first point is very steep, right? The slope is steep. The second point, the slope is also steep. But the third point, the slope starts to level off, right? Okay, the criteria is, if you refer to the script plot, look for account for the point where before it start to level off. Count the number of points that is before it start to level off. So it start to level off here. That means you don't count here. You count only 1, 2 before that. So that means in this case, how many factors to be extracted? 1, 2.
2. Okay. Understood. Thank you, Doctor.
So currently what we observe, the first criteria, which is Kaiser criterion, eigenvalue more than 1, 2 factors. Based on script plot, also 2 factors. So far it's consistent, right? Okay, now we want to refer to the third method, which is the Monte Carlo parallel analysis. So are we ready now for the third method? Okay, for the third method, please open your Spss syntax editor. Everyone, open your syntax editor. Okay, this is my syntax editor. Okay, we have already deleted the stretch of command from start until end. Is that right? Just now we have already deleted. Okay, the next step, we need to edit the name of variable in our data set. So in this case, instead of var1 to var9, our variable name are v1 to v12. That is the variable name that we want to enter into this syntax editor. Get raw /file equal star, missing equal omit, var equal, var here refer to variable equal v1 to v12, and the next thing to be edited will be to be changed. Instead of 100, put another 0, it become 1000, and that's it. So let me repeat what we have done in relation to this Monte Carlo. Step number 1, go to the website. Step number 2, go to the Spss rawpa.sps, and then open the file. Okay, once you open the file, copy the whole content of that document, and then go to your Spss, click on file, click on new, click on syntax. That means we open a new syntax editor, and then paste that command into the syntax editor. Next step, we go to line 58, if I'm not mistaken, just now line 58, and then highlight that line until that start artificial data until end artificial data, right? And you highlight the whole stretch of command, and then just simply delete. After we have deleted that set of command, the next step, we need to change the name of variable according to your data. According to your data, so in this case, in our example here, we are using v1 to v12. So instead of var1 to var9, change to v1 to v12. And the next thing that we need to change will be here, compute and that sets equal 100 to 1000. Okay, once done, are we done? Are we done?
Yes.
Okay, the next step, click on run, menu run, and then click on all. I mean, we want to run this procedure. Okay, click on run all. When you click on run and all, okay, what we need to look for will be, let me change the window to the Spss viewer. Okay, when I open my Spss viewer, we look at here, this one here, the matrix, and then we have raw data, eigenvalue, mean, percentile, and then what we need to do will be root, raw, mean, and percentile. So what we need to compare will be, we need to compare the value under raw data, that it will be the actual eigenvalue, and then compare that against percentile. And this is the 95th percentile, 95th percentile. So the criteria is, if the value for raw is bigger than value for percentile, then that we accept that as one factor to be extracted. One factor to be extracted. So in this case, the first factor, the raw is 3.838. The percentile, which is 95th percentile, the value is 1.35, 1.345, is that right? So that means the raw is bigger, therefore we have the first factor. Okay, let's proceed to the second factor. 2.149 for the raw, for the percentile, 1.254, which is also bigger, is that right? So therefore we get the second factor. Okay, when we go for the third, the raw data, the eigenvalue is 0.917, but the percentile is 1.189, is that right? So which is lower, is that right? I mean, the raw data, the value for the raw data is smaller than the percentile. Therefore, we don't extract the third factor. I mean, we stop at only two factors, factor 1, factor 2. So what we can get from here is, based on the first criteria, Kaiser criterion, two factors to be extracted. Based on scree plot, two factors to be extracted. Based on Monte Carlo, two factors to be extracted. I mean, we have very strong justification to say that we are going to extract two factors from this EFA. Right? That means,
possible tak kalau kita buat tiga ni kan, Monte Carlo apa semua ni, tapi dia berbeza. Contoh dekat sini 2, kat sana dekat test yang lain tu 1 je. Ke dia memang akan konsisten je?
Possible. But if you get something like this, will be better, right? Because consistently, the three procedures shows the same number of factors to be extracted. But it is possible. But if it is different, then you make your judgment. Which one that you want to use. But of course, in most cases, as I did mention earlier, when we run for this factor analysis, we have the set of variable. We have each variable, we have the instrument. And each instrument, we know the item for that instrument, the item or the indicators for that instrument, right? That means how many factors will be the number of variable in your data set. Is that right? That means if they happen to be the same, I mean, that will be stronger. But in case if it is slightly different, then you make your judgment. All right? Does that answer your question, Nabila? Bila nak pergi Turki ni? Pergi Turki masa tulip lah, masa apa ni, musim tulip. Barulah orang perempuan baru suka tengok tulip kan. Okey, tak apa.
Participan baru boleh pergi.
Oh ya, okey, tak apa. Okay. Are there any question? So is it clear how we determine the number of factors to be extracted? Step number 1 is we test for the sampling adequacy. We test for the identity matrix, and we don't want to have identity matrix. We have done that. Now we proceed for step number 2, where we are testing for the how many factors to be extracted. We use the first criteria, which is Kaizen criterion, and the second we could have been using the scree plot. And third procedure, we use the Monte Carlo parallel analysis. And what we get, all the three shows consistent result. Okay, so now we proceed to step number 3. Step number 3. What is step number 3? Rotation and interpretation, right? Rotation and interpretation. Okay, now let's go back to the So the output from the factor analysis. Okay. Earlier, based on the result, we have these two factors. So if you look at the initial component matrix, these are the two factors: factor 1, factor 2. Factor 1, factor 2. Okay. So now, in order to make it more meaningful and easy to extract the item, so we go for the rotation. We have already requested for the rotation where we use the Varimax. Remember the orthogonal, the uncorrelated method. If you look further down, then you have this title called rotated component matrix. And this is the one that we want to refer to. Instead of the initial, we refer to the rotated component matrix. So everyone, please focus your attention to the rotated component matrix. So how many factors based on the Kaiser criterion, the script plot, as well as the Monte Carlo? 2 factors, right? So these are the 2 factors. And these are the items that we have in this analysis, V1 to V12. Okay, now, which item should fall into which factor? So if you were to use this, when we don't request for any option, I specifically don't request for the option because I want to show if you don't click the option, this is the result. That means you have to do manually to decide item 1 fall under factor 1 or factor 2. Item 2 fall under factor 1 or factor 2. Okay, now if we were to use this result, V1, that means the factor loading, this value here are called factor loading. We look at the factor loading, which one is higher? So for V1, it seems that factor loading for factor 1 will be higher, is that right? Therefore, V1 should fall under factor 2. V2 should fall under factor 1 because the factor loading is higher for factor 1. V3 should fall under factor 1. V4 should fall under factor 2. V5 should fall under factor 1. And then V6 should fall under factor 2. V7 factor 2. V8 factor 1. V9 factor 2. V10 factor 1. V11 factor 1, and V12 factor 2. Is that right? And I mean we have to do line by line to compare. In this is you have only 2 factors. What happens if you have 6 factors or 7 factors? I mean, it's quite troublesome for you to identify. For that particular item, should fall under which factor, right? I mean, if we don't tick for the option, that means we need to do manually decide based on row by row by comparing the factor loading for factor 1 and factor 2 and look for the highest, and that will be where that item should fall into which factor. Okay, but now I want to share the first option. Are we ready? We have hard time here, right, to identify the result. Okay, now I want to share the second or the option. Okay, please click on dialog recall and then click on factor analysis. I mean, we want to go back to the procedure just now, factor loading. But now, once you get the factor loading dialog box, we need to click the option button. Okay, everyone, please click on the option button. Okay, now tick the option for sorted by size. We request Spss under this the EFA procedure to sort the factor loading, to sort the item based on factor loading, based on factor loading, sort by size. Okay, so now click on continue. I didn't request for the last option, but we will request. You can see the importance of the 2 options. Right? Currently, we just select one option where sorted by size. Okay, click on continue, click on OK. When you click on OK, simply go to the result earlier for rotated. See, these are factors. These are items that fall under factor 1 from V2 up to V5. I mean V2, V8, V11, V10, V3, and V5. That are items that fall under factor 1. And then which item should fall under factor 2? Starting from V9, and then V12, V6, V1, V7, and V4. I mean, this has been sorted by size. Then you can see clearly, is that right? You can see clearly the item are sorted accordingly. Okay, now the next step, we try to look for another option, which we can appreciate the last option. I mean, we choose both, sorted by size as well as surprise. We want also to surprise. Okay, so what is it that we need to surprise? Okay, so go back to dialog recall, and then factor analysis, and then option again. Tick also the second option. We have already ticked the sorted by size. Now we also want to suppress small coefficient. And the small coefficient here, okay, according to our result here, maybe 0.45. 0.45. Right? Okay, once you change to absolute value below 0.45, I mean absolute value include minus and plus. It doesn't, because absolute, we just consider absolute value. Okay, click on continue, and then click OK, and then go back to the result, and you can see, and you should be able to appreciate the result better, yeah, right? I mean, now any factor loading that is less than 0.45 will not be listed. I mean, will not appear on the screen, on the in the output. So we can see clearly, okay, these are item for factor 1, these are item for factor 2. Is it right? Any question? Okay, any questions so far?
Why we choose 0.45?
Okay, why I choose 0.45? Because if I observe earlier, the lowest factor loading for factor 1 is 0.473. 0.473. If I put 0.5, that means this item will not be listed. That means the factor loading for this item will not be displayed. That means that is the rationale. That means you look at the result. It's not every time we have to go for 0.45. I mean, we look at the result. So in this case, the more proper value to be used as the cutoff point will be 0.45. Because why? Because we also want to include this V5, where the factor loading is 0.473. You can put 0.47, still okay. Is it right? So that's the right rationale, but not every time we have to put 0.45, because we look at the result, and from the result, then you decide what should be the minimum suppressed value. Does that answer your question, Yogasri?
Thank you.
Okay.
Thank you.
Yeah. Okay. Others, any question? So basically, from this analysis, we have got the result. I mean, we know that from the 12 item initially that we have in our data set, when we run for this factor analysis, 2 factors were extracted, and the 2 factors are listed on the screen, where for factor 1, we have how many items there? We have 6 items, 6 items, and for factor 2, we have also 6 items. I mean, evenly distributed. 6 items for factor 1, 6 items for factor 2. Okay, no questions there, right? If there is no question, then I want to share how to calculate the percentage of variance, the overall percentage of variance. Second, we want to calculate the eigenvalue. Third, we want to calculate the percentage variance for each of the factor, and percentage variance for overall, based on factor 1, factor 2, and overall. Okay, let's go back to our notes, because the notes will share you the step-by-step, the calculation, so that next time, if somebody were to present you the result, at least you can assess whether the result is accurate or the result is tempted. Something has been done. Instead of typing 0.4, the candidate type 0.7. So we don't want that to happen. Okay, now let's go back to this. Okay, we have done this all. I mean, the step-by-step, you can follow in the notes what need to be done. Okay, this is the result. Okay, interpretation for the result. So the factor loading, as mentioned earlier, when we look at the component matrix, we want the value to be, the minimum is 0.3. 0.3 considered to be mid-minimum level. But if it is 0.4, plus or minus 0.4, considered to be more important. But if it is more than 0.5, practically significant. I mean, even though the minimum is 0.3, but we would be better for us to go for higher level or higher factor loading. We want it to be 0.5. But even as I did mention, if we go for CFA, 0.5 is not good enough, because if it is 0.5, your AVE, average variance extracted as a measure for the convergent validity, is only 0.25. But the cutoff point for convergent validity, to meet convergent validity, AVE must be 0.5 or more. The minimum will be, the cutoff point is 0.5. So if it is only 0.5, you square this value, you get only 0.25. That means way below the cutoff point in order to meet the convergent validity. So that's why at this point for your EFA, yes, it's acceptable 0.5, but in reality, if you go for the next stage, where if you proceed to structural equation modeling, where you run for your CFA, we want the value for the factor loading to be more than 0.7 minimum, 0.7 on the average, minimum 0.7. Okay, that is the factor loading. So what we need to look for here will be as an indication, is there any value that is, this is the common method idea here, not commonality. Okay, here. When you refer to the value for the table for communalities, okay, you look at the value. If the value is less than 3, if you have any value less than 3, in this case, we have one value, V5, where the extraction value for communalities is 0.24274, is that right? Which is less than 3. I mean, we would expect some problem with this item. When we look at the result, we would expect something not proper or something not good with this item, where the item of concern is V5, because the value is less than 0.3. It is only 0.24, 0.242. So when we refer to the result again after this, we would see that maybe the factor loading will be low, or might be, it may fall into two different factors. I mean, it fall under factor 1, it also fall under factor 2. I mean, the factor loading are about the same, not that much different. Okay, that is the communities. And what is important here will be, based on this value for communities for extraction, if we were to add this value together, if you get the total, and we divide by number of items. So we have how many items in our analysis? How many items?
12.
How many items?
12.
11.
12, right? V1, V2, V3 up to V12. I mean, we have 12 items. So that means the item here is 12. So that means total of communalities divided by number n, which is in this case the number of items, and then multiply by 100. That will give you the total percentage of the overall that we will be getting. Okay, then if you were to follow through the calculation, okay, the total variance explained equal to total of communalities divided by n. N here refer to number of item or indicators, and then multiply by 100. So in this case, if you were to add all this value here, the total is, I mean, I'm using Excel, Excel. I mean, if you want to get accurate calculation, you need to go not just 2 or 3 decimal places, you try to go more, so that the result will be more accurate and then comparable to your Spss output. So that means if you were to get the total communalities is 5.98882. Is that right? So if you were to enter to the formula, 5.98882 divided by 12, multiply 100, the total percentage is 49.907. And I mean, from the factors that we extract, they explain 49.907% variance. And that is how we calculate the total variance explained. Okay, next, you see, and where to get this 49.907? If you look at the total variance explained table, it is reported here. The total of this is cumulative, this is percentage variance. This is the cumulative percentage. I mean, total up 49.907. That is how they derive that value for 49.907. Right? If you go for the initial 49.907, if you go to the we go for the rotation also 49.907. If you go for the rotation result, is also 49.907 total percentage variance explained. Okay, that will be how they calculate for the total percentage explained. Next, we want to calculate the eigenvalue. What is eigenvalue? Eigenvalue is the total of the squared factor loading for each column. Total for squared factor loading for each column. So in this case, this is the unrotated. This is the unrotated component matrix referred to the unrotated solution. Okay, that means we have factor 1, factor 2. So these are the factor loading. That means we just need to square each value. But if you want to calculate the eigenvalue, make sure don't suppress the factor loading. If you suppress the factor loading, that means some of the factor loading will not appear, is it right? I mean, we suppress just to see the result much clearer. That is the purpose why we suppress. But if you want to calculate the eigenvalue, we must make sure that all the factor loading will be displayed. And then what we need to do now will be, for factor 1, this is the factor loading, we square each factor loading and get the total. And then for factor 2, we square the factor, this is the factor loading, we square the factor loading and get the total. And now, that will be the eigenvalue for factor 1. This will be the factor loading for factor 2. Right? I mean, if you refer to the output just now, total variance explained. For factor 1, 3.839, 3.839. For factor 2, 2.150, 2.150. I mean, round up error, because if you go for more decimal places, we should be able to get 2.5, 2.150. That is how they calculate for the eigenvalue. How? We just get the factor loading for each column. For each column refer to each factor. Square the value, square each value for the factor loading, and just simply get the total. And that total will be the eigenvalue for that factor. For the other factor, to do the same thing. Get the factor loading for each of the item for that particular factor, and then square each of the factor loading, get the total, and the total will be the eigenvalue for the second factor. Right? Okay, any questions so far? How to calculate the percentage variance as well as the eigenvalue? Is it clear?
Yeah.
Okay, good. Yeah. Clear is not good enough. If it is crystal clear, that will be better. So is it crystal clear by now?
Crystal clear, inshallah.
Okay. Why? Because sometimes when I go somewhere outside, and I hear crystal clear. Somebody mentioned crystal clear. They still remember me when I had discussed about this factor analysis. Crystal clear, right? Or I always use the word, "Are you crystal clear?" So when they meet me somewhere, some of them says crystal clear. I know that this is my student for statistics. Okay, so that are how we calculate the percentage variance, total percentage variance. And then as well as how to calculate for eigenvalue for each of the factor. Okay, next, we want to calculate for each factor how many percent variance explained. Okay, now, in order to calculate the percentage of variance explained by the individual factor, this is the unrotated. So what we need to do will be the percentage variance for that factor equal eigenvalue divide by number of item, and here refer to number of item, multiply by 100. So if we were to take the first factor, the eigenvalue is 3.839, is that right? So if we were to calculate the percentage variance, will be 3.839 divided by n, which is 12, multiplied by 100, 31.991. 31.991. So this is the unrotated. This is the percentage variance for the unrotated, 31.991. See, and that is how we calculate the percentage variance for factor 1. This is the unrotated solution. For the second factor, the eigenvalue is 2.150. So we just enter into the formula 2.150 divided by 12, the number of item, and then multiply by 100. That will give you 17.916. If we refer to the unrotated solution, 17.916, right? Okay, and what is the overall total? For the overall total will be just simply percentage for factor 1 plus percentage for factor 2. So in this case will be hari ini banyak tak betul. What happened? It doesn't move. Okay. Or maybe enter. Tak jalan juga. Okay. I mean, in this case, you just need to add the percentage of variant explained for factor 1 plus percentage of variant explained for factor 2, which the total should be 49.907. That will be why it doesn't move? Okay, so I have to stop sharing first. Stop sharing also doesn't work. MashaAllah. Okay, since it doesn't move, so it's not responding, then my computer is not showing something wrong somewhere. Okay, so now the one that I share you currently is how to calculate percentage of variant explained for factor 1 and factor 2 based on the unrotated solution. So we get the value for factor 1, which is 31.991, and the percentage variant for factor 2 is 17.916, and total is 49.907. And if you go to the next slide, I show you how to calculate eigenvalue for the rotation solution. I mean, it should give you the eigenvalue for the first factor and second factor already done, but the percentage variant. The percentage variant for factor 1 will be the 25.325. And for factor 2 will be 24.582, and the total is 49.907. And then if we were to proceed further, stuck. If we were to proceed further, what next? What next? So now, hopefully everyone are clear on when the one that I share for the calculation. First of all, I share how to use table from commonalities to calculate total percentage variant explained. Whatever we have done, we just simply total up the value for commonalities, and we get the total, and then we divide by number of items. So in our case is 12, and then multiply by 100. That will give you the total percentage of variant explained. Next, what I have shared through our discussion just now, I share how to calculate for eigenvalue for each of the two factors. Okay, how to calculate the eigenvalue for each of the two factors? We just need to square for each column. Each column refers to each factor. So square each factor loading in each column, and then just get the total. The total will correspond to eigenvalue for factor 1, eigenvalue for factor 2, which is just simply the summation factor squared loading for each of the column. You get your eigenvalue. Once you get your eigenvalue for factor 1 and factor 2 in our example, so in order to calculate the percentage of variant explained for each factor, the formula is just simply eigenvalue divided by n multiplied by 100. Okay, so that means if you were to use the unrotated or the rotated, the same procedure is applied. I mean, by right, everyone are clear on how to calculate the total percentage, eigenvalue, and percentage of variance for each factor plus the total. So any questions so far? Finally, the last topic that we want to discuss will be on what next? What next? Okay, any question? Are you still with me? Any response?
Yes,
Yes.
we are still with you.
Otherwise, I'm talking to myself. Okay, Dora, any question so far on the calculation part?
Actually, I want to ask, do we need to report the results of the variance explained value?
Yeah.
Or
If you look at my notes, if you look at my notes, I give the table and I indicate the percentage variance explained for each of the factor. That means if you refer to the, that means it's embedded into the table that we want to present as the result for factor analysis. Yes.
So in our thesis, we need to report the value of the eigenvalue as well as the variance explained.
Yeah, yeah, of
Okay,
course.
understood. Okay, thank you, doctor.
But you don't have to show how the calculation is done. That one you don't have to show.
Yeah.
I don't need to show. Otherwise, your supervisor will say, "Oh no, too much, Dora. You have been writing too much. You don't have to explain this. You just need to report and you just need to highlight. That's it." Okay. Others, any question?
So the process of the calculation is only the principle of how to calculate to get the results.
I just want to share with our friends here, our members here, how the values are derived so that we can appreciate the value better. That is how I learned. When I know how the value are being derived, then I can appreciate the value given in the output better. Otherwise, 49.07. So what? So that is
understood.
But we don't have to share how the calculation is done in our thesis. Okay, others, any question? Otherwise, let's go for what next. Okay, what next? If let's say now V1 to V12 are just items that I prepared, but I don't have any idea what are the variable that I'm dealing with. Of course, I have some idea of what aspect of thing they want to do. So the next thing that we need to do will be we look at the item for factor 1 that fall under factor 1, and we look at the item that fall under factor 2. Look for what is the common themes that is being embedded into item for factor 1, item for factor 2. Okay, based on that common theme, then we label that. That label is actually your variable. If you don't have the variable yet, I mean you need to label based on the common common themes embedded within the item for that particular factor 1 and factor 2. That is step number 1. But if let's say now you have already identified the variable, what is variable 1, what is variable 2, that means you just identify, okay, variable 1 is this, variable 2 is this. But if you don't have any label yet, no variable name yet, then we look at the item and what is it that is common for all the item, and then you assign one name for that variable. That item, that factor is your variable. Okay. What next? The next step for each, and in our example, we have two variables, factor 1 and factor 2. For each variable, we need to test for reliability. Test reliability for factor 1, test reliability for factor 2. How to run for reliability is what we have done earlier. We click on which menu that we need to click. We click on analyze. What next? Analyze next. What next? Analyze and then
scale.
And then what next on the right?
Reliability analysis.
Okay, once you get the reliability dialog box, so simply enter item for factor 1 into the right box, and then click on statistic, and then tick the option for the three option on the top left, right? Scale, scale if item deleted. That means we just tick that three option, and then you run for factor 1 or variable 1, and also run for factor 2. Okay, we want to make sure that the two instruments are reliable. We want the value to be more than 0.7. Okay, that will be the second step that we need to do. What next? The last step will be we need to calculate the factor score. The factor score. I mean, if you go to the Spss procedure just now, there is one option where you can save as factor score. If you recall, when we run, saya ada masalah, saya tak boleh. I can't do anything now. Let me try again.
Prof nak buka slide nombor berapa? Kita sharekan screen lah.
Tak apa, it's okay. It's okay. Tak apa. So what we need to do will be after we have done the analysis, we get the result. We present the result as what you can see on the in the notes, the table, and then we proceed to assign label. We proceed to test for the reliability, and finally calculate the factor score. Okay. If you look at the option given in the factor analysis, there is one button where you can save as factor score, right? That will be one option. But you can use that option, because that if you would use that option, I mean, when it calculates for the factor score, it take into consideration the factor loading in order to calculate for the factor score. But if you want, you can use the normal procedure where we calculate the mean summated score. That means we consider all the item of equal weightage, and we just calculate the mean summated score. That is another procedure that we can do. But in most cases, I don't use the option for the factor score, but I use I calculate manually using transform and then compute variable, new variable, and we calculate the mean summated score for each of the factor or variable. That will be the end of our EFA exploratory factor analysis. Okay. You can refer to the notes. You can refer to the notes. So before we stop, so in case you have any question, you may want to put your question to me. Otherwise, what is our time? Oh, the time is already 5:25. 5:25. But now, even if I want to close this, so I can't. Okay. Any question? Okay. Any question you may have? Okay, Yati. Since Yati is on my screen. Any question, Yati?
So far, no.
Is it clear?
But I need to do.
Have you been using factor analysis before?
No problem.
Okay, so that means
It's my first time.
First time, if you get clear picture of what to expect, what need to be done, what you need to understand, I'm happy. But remember, if you just put aside, you don't practice, everything will go on with the wind in no time. So the keyword is practice, and if possible, any data that you have, run so that we can see in the first place what you need to understand, the basic about factor analysis, and then you need to understand the step in factor analysis. The first step, we test for the requirement in terms of sampling adequacy. We want to test that it is not an identity matrix. And then the second step, we want to extract how many factors to be extracted. We have that 3 options that we can choose. We can run for all the 3. And then the last step will be rotation and interpretation. And then what next? And that 3 step, we assign label. If you have the variable name ready, you just assign. Otherwise, we look at the item and then assign name based on common themes. Second step in the what next will be run reliability, and finally we calculate the factor score or the mean summated score for that individual factor that we extract from the analysis. Okay, so any question before we stop?
Prof, I have one last question.
Ya, kata last ni kan tak boleh tanya lagi. Another question. Okay.
Okay. Macam for example, if I want to check the questionnaire that I want to use instrument for my research. So for example, if I take the existing one, so I want to see the strength. So I look at the factor loading of every item, is it?
Yeah.
So it has to be more than 0.5.
At this stage, it is more than 0.5, the minimum. That is practically significant. Remember the criteria mentioned earlier. But the higher the better. The higher the factor loading, the better. That means the item clinch together to measure that construct.
Okay, so means that 0.5 tu adalah minimum dia.
I mean, practical significant criteria to be used for the minimum cutoff point. Yeah.
Okay, so in case we take the established scale and then we add to our research, do we have to run again? We have to run again lah kan? Sebab kita dah add.
Yeah, of course you need to run.
The factor loading. Okay.
Yeah.
And use the Python for that.
Good to have Nabila in our class because she's active. So we hope that others also will post question, because sometimes when you just hear, maybe it make you understand, but a lot of time maybe you have some doubt on something. Because when I share the material, not necessarily every one of what I mentioned is understood by all, right? So I would expect this type of response where you ask question. When you ask question, you learn to understand better, and also help others to learn. So we don't see when we ask question that we disturb others. I don't look that way. So thank you very much, Nabila and the rest of who are actively involved in the class discussion, so that we can try to make sure that the class is as effective as possible. Okay, others, any question?
I think
Okay,
it's
the
not.
last question.
Last question.
The last question on our assignment 1, the due date is this Sunday, right?
Okay, the same data as we did for the assignment 1. That means just continue.
Yeah, I mean the due date of this of assignment 1 is this Sunday, right?
Yes, still Sunday, next Sunday. Not this Sunday, but the following Sunday. That means you are given slightly more than 1 week to work on your assignment. Every assignment, you are given how many days? About 10 days, yeah, right?
Okay. Understood. Thank you, Doctor.
Okay, welcome. Because Dora want to help our members from China to submit to me their assignment. So that means when Dora would to submit, I would expect the compilation to be thicker, because compilation of few students. Okay, others, any question? If there is no question, then thank you very much for your attendance in this class, for the third class for this subject. And we hope that everyone learn your EFA, exploratory factor analysis. And we hope that when you work on the assignment, hopefully you should be able to learn to further reinforce your learning, inshallah. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullah. Thank you, Prof.
Okay, welcome.
Thank you, Prof.
Thank you, Prof.
You need to switch off, because I will take more time, because my computer is stuck currently, so I can't stop the.
Thank you, Prof. And
Okay,
goodbye.
thank you. Bye-bye.
Bye-bye.
Normally I will stop the session, but now I have got problem with my computer, so you can just leave, because it may take me some time to clear the things. All right, so
Bye.
see you all next week, inshallah.